in a K-pop band last night. This is how they all do it.
Yeah.
Yeah. We're gonna.
Yeah.
Yeah. Oh, I'm just gonna do some intro, so I'll bring you up.
Yes, they are.
I'll bring you up.
Sit down until
Okay.
Sweet.
I'm gonna get the mic.
There you go.
Okay. Are we ready to go?
Where's the calico? Or that shouldn't sleep anymore. Want me right now to get him? Oh, right here. He's right here.
Okay. Okay. So ready to go?
Sure. Let's go.
Okay. Good morning, everybody. Welcome to Cloud Native Day Los Angeles 2025. This is seventh time I'm doing this event, I think.
It's been a minute, yeah.
It's been a bit. It's had a couple of names. It was started out as Container Days LA, and then it was Kubernetes Community Day LA, and now it's Cloud Native Days LA. But either way, we're going to bring you all of the new Container Cloud talks from a whole great variety of speakers. This morning, if you didn't catch it from the update, we have a little bit of a schedule change. The awesome Tim Banks unfortunately couldn't make it because of major flight issues. And as such, Kelsey Hightower graciously offered to do a chat about the current state of the cloud with Justin Garrison.
We have questions.
Yep, who is part of the Cloud Native LA team here. There's actually 6 of us currently in the program committee for the Cloud Native track, and we put this together every year. But before we get started with the fireside, actually here.
There you go.
You want to?
Yeah, if you're here for the Cloud is Reckless, welcome. The board says that. The printout says that. That's not what's actually going to happen. You made it to the right room, but why did it disconnect now?
I don't know.
It's an iPad, man. I do have a Linux laptop, but other problems. But anyway, I'll get that working again. I did interview Tim on my old podcast called Ship It Show. If you look for the Zookeeper of Jiu-Jitsu, it's a very unique SEO-friendly word that you can find. We did talk about some of his ideas around that, which I think are really good. And so it's a podcast that meanders a bit. But if you want to have some content of what Tim was talking about and why he thinks the cloud made us reckless, then you can listen to some of it there.
Yep. But before we get started, we want a word for our sponsor for Cloud Native Day LA, which is Tigera.
Thank you. It's awesome to be here at SCaLE and awesome to be here in Southern California. Come check us out at the table outside. We have some great T-shirts, and outside of T-shirts, we also make software. So if you're familiar with Tigera, as Kelsey was saying, we're one of the original container networking interfaces, CNIs inside of Kubernetes. So we're widely deployed in almost every environment, every distro. And on top of container networking interface, we have some commercial products too. We can do everything from ingress, egress, observability, security, end-to-end security. So come check us out. Come talk to myself, and Kartik is at the table right now. And we'd love to give you a demo. And again, thanks for having us out here. All right, thanks.
Thank you, and thank you very much. And by the way, if you work for a cloud company, you'd be interested in sponsoring Cloud Native Day next year, you can talk to me or Justin or Ilan from the conference. So with that, let's actually get started with our fireside chat.
And if you don't know Kelsey, obviously retired from Google 3 years ago? Year and a half. So you're still in your retirement now. But you've been doing these fireside chats ever since, basically, right? So it's like if you haven't seen Kelsey talk, but I feel like you've been a liar at all of them.
A liar?
A liar, because there's never been any fire. And so we have a picture of fire, which is close enough. Anyone has a lighter, you can hold it up and just point it towards the stage, because, I mean, you've been...
I don't fire in LA right now. A little too soon.
There you go. That's close enough.
There you go. Light. A light side chat. You know what's funny? Tigera, I had a little open source project called CompD. It's right around 2012. I first learned Golang. And I left a company called Puppet Labs, recovering DevOps system administrator, and I wrote this little mini lightweight configuration management tool called CompD. It pulled key values from etcd and generated a template. And the first commercial product that ever shipped it, I believe, was Calico. I was getting some GitHub issues, and I was like, why is this so important to you? It's like, oh, we ship it as part of our commercial thing. I was like, you're making money, none's coming my way. So that's the short story between me and Calico. They were the first commercial entity to ship my product to other people and just buried it in their offering, but made me proud nonetheless. So shout out to the Calico team. I'm filling in for Tim, as you all know. I like Q&A from the audience the most. We can ask random questions. We were good friends. I've known him for years, the early Kubernetes days. But I know a lot of people have their own questions. Any questions, fair game. I don't work anywhere. I have nothing to sell you, have no reason to mislead you, and I promise to give you the most authentic answers possible. So please don't be shy. Let's take advantage of being present together. So
I would
welcome.
want one question to start it off.
Yeah, go ahead.
To hear your opinion on Tim's take on, has the cloud made us reckless?
You know what? I was in Austin with Tim. We went to some taqueria in Austin probably about last year sometime, and we were having this debate. I'm coming from Google Cloud as a cloud provider, and part of the debate is the cloud is complex. It's too complex, you don't need it. And my defense was, well, how do you think it got that way? If you are a customer of any cloud provider, every feature request that you've ever asked for, every little thing that you needed to do your job, times 1 million people globally, you're going to end up with a complex system no matter how it shapes up. So if the cloud is complex and reckless, it's our fault. Everyone that uses it, every flag you ask for, every little integration. After 7 years working in cloud, there's one thing that I come to realize. Most people want the new thing to work the old way. If you're using VMware, I never thought I would see the day that every major cloud provider would have a VMware offering. And customers were like, yeah, now I have VMware too. I'm like, in the cloud? We really repeated the same thing on-prem. It's like, yeah, and I want Oracle in the cloud. And so I think, yes, it's reckless because we've taken away the justification process of getting infrastructure. If you want to build a bridge, you got to justify it. There's real work that goes into it. You need to plan because you just can't start a bridge and not finish it. I mean, maybe some people have done that, but there's a cost. But in the cloud, you're just like, I need some VMs. Click. It's not your money. Most people don't know how much this stuff costs, so you just leave it running. It's insane that we're so far decoupled from the actual cost of cloud that we have become reckless. It is reckless. The way people write code, npm install the internet. Like, what does your app do? It's like, oh, no, we just read a text file and return it as JSON. But, so why you have OpenAI in the mix? It's like, I don't know, man, just in case. This is reckless.
That's VC funding.
I mean, but people don't even have any money. They don't have any customers. So I do think it's made us reckless because you don't even have to justify the thing you're doing anymore, right? When you have a little bit of RAM, very little disk space, you have to think about things before you write them. So then you only write the things that are necessary. But a lot of people are like, I'm just going to do microservices. I'm like, but why? It's like, I don't know, man. I went to KubeCon, and people had this slide, and I want a slide like that, and I wanted to improve my LinkedIn profile. So I made microservices to read something from the file system. And I think this is the irresponsible nature of software engineering because without constraints, it's really, really hard to do solid engineering. You almost have to have discipline or experience to guide you to the most. I think I agree with his points. I don't know how he was going to arrive to those points, but as someone that lived cloud, thank you for the revenue. I retired early because of it. But it's literally based on reckless spending. I think most people in the cloud are less than 10 to 20% utilization, and they just spin stuff up. Every new idea, they just spin it up, and no one asks any questions about it. So yeah, I would say I agree with it.
Question.
I'm going to run the mic, and
We have
questions.
We have a live stream, so we want to keep the questions on the mic if you can.
So, coming from like a DevOps background, for more the ops side, I think we would probably agree that maybe the automation has abstracted away the need for understanding. in some of those situations where the cloud has made, for lack of a better term, made us reckless. So because of the lack of understanding, like maybe we have a tougher time troubleshooting or keeping up services. So if that's true, if the answer to that is yes, what would be one thing you would encourage everyone to understand about the cloud, like specifically from like an ops perspective?
2007, I was working at a company called Total Systems in Atlanta. It was like my first real job where you got to wear jeans only on Friday. And I had thought I made it. It's like, yo, they pay a lot more than my previous job. Everything's professional. They got all the changes we're going to do tonight on a spreadsheet. You do them in order. Check the logs, all clean, all right. Type the Unix command. And what I realized is that most people doing this work, and there's no knock against anyone, what the app is written in, what frameworks, memory usage, performance benchmarks, algorithms, data structures, nothing. Give me binary, run binary. Binary not running, restart binary. Binary's running now. Install Nagios, that's not cool, Datadog. And then you're just guessing, and we call it observability. You're just guessing. You're just driving the car. I don't know what the speed limit is, but I know I'm driving about 60. That seems all right. Oh, I crashed. Maybe I should slow down. Maybe I'll just drive at 50 from now on. So most people just don't know how the thing works. So if you're automating something that you don't understand, you're usually just automating a terrible practice. And the best automation engineers I've ever worked with, or whenever I had the most success, I always come in and just do it manually. Just slow down. Read the code. What does it do? There are no errors for this error condition. We don't even log it. Everything's an error. Right? So, oh no, you can just ignore those. Like, have you seen this? The number of regular expressions people have in like their syslog config? Yeah, those are good errors. It's like, but why is it error? How about we just reclassify the log statement to make it actually match its intent, because then we can actually do real automation based on the metadata about the actual log message. So instead we do a lot of this reverse engineering, creating a lot of fires for ourselves. And then I think this is where we start to lose the ability to find time to dive deep and actually do stuff at that level. So to me, I would say, learn how the thing actually works. So at that company, TSYS, we were starting to adopt Puppet. So before I joined Puppet Labs, I was using it in production. And I was trying to get the company to make it a little easier to use Puppet instead of writing scripts and translating them into Puppet code. That's what people were doing. File, package, service, exec statement with the bash script that you were trying to replace because you never got it to work. And I remember the first thing I did was I took time to package every Java application in an RPM. I learned how to make an RPM spec file. I learned what the JVM does. I understood what everything in the class path was doing. So instead of blindly copying this directory with a bunch of Java jars, I started removing them until the app didn't work and started putting them back until it was right. And I knew exactly what belonged in the class path. So when I made those RPMs, they were so clean and predictable. And once we had RPMs for everything, then I wrote the Puppet code. Then it got back to that holy grail of file, package. Where did the package come from? Yum. You could do yum install any of our apps. And it simplified the whole process. And then I turned my attention to the logs. And the team was like, yo, we got other stuff to do. We're writing production code. There were financial services. And so they had valid reasons not to do that kind of work. And so what I did was, I remember I went to the bookstore, a place called Barnes & Noble. And you walk in and you can literally like buy a physical book and take it home. No DRM. And every Java book around 2009, there's always the bicycle example to teach you object-oriented programming. So I'm like, why am I learning about wheels and bikes? I just want to know how to write logs. Log4j is all I need. And I remember that weekend, I learned just enough Java to figure out log4j. Got access to the production code, and I started reclassifying the logs. And it was my first commit coming from ops into the dev world. And the dev team was like, hey, who made all these log changes? Like me. I understand syslog really well. I understand what could help the whole team get more accurate logging and metrics and monitoring, but I really, really need these changes. And there was a guy named Dan Merchant. He was like, damn, no one from ops has ever looked at the code base before, let alone attempt to make changes. And he showed me my mistakes, and we finally got it merged in. About a year later, I was writing features for the platform. But I understood the app so intently that I was able to marriage Puppet and all the work we were doing into a holistic whole. And then I really felt like I was doing DevOps at that point. And so when I was invited to those early meetings, you know how in DevOps, like, man, why wouldn't they tell us that they're going to add RabbitMQ to the stack? That would be good to know before deployment. But when I got invited, I understood exactly why, because I saw in the code base. I started to track the code and knew what it needed. And there was no more justifying why we're adding RabbitMQ, because I knew what the new architecture was. So my thing would be is like, learn how it works. This reverse engineering and claiming that that's operations, I think we're just doing a half measure there. Sure, some people just want us to restart the servers in the middle of the night, but I think we all have the skill set and aptitude to do much better than that. Another question. I'll let you run and return the mic.
I may be about to start a fight with this one, but increasingly it seems to me like we're getting into a scenario where there are basically two types of open source software. There's community maintained open source, which has problems of maintainer burnout, but it does have a true community and it's under, endorsed open source licenses. And then there's corporate maintained open source where, yeah, you get a support contract, but it's under an open source license that isn't really open source anymore. And I wonder if there's a way back from, well, first of all, do you agree that that is increasingly true, that we're seeing that dichotomy? And if you do, is there a way back from there before we end up with those two camps like irreconcilably divided?
Man, open source is like a religion. I think I started my career in 1999, right out of high school. And I remember that there's Solaris, AIX, and most of the stuff you just couldn't even afford to try it. You go to CompUSA and they got that Linux magazine, and there's this CD-ROM in the back. I was like, ooh, free software. And you put it in there, I was like, wow, all these volunteers put in all this effort to make this work. That remains. If you have a problem with open source, you literally, you by yourself, can go and write all the software you want and decide. You can choose any license you want by yourself. And you can publish the code by yourself with no help from no one. That's what you can do today. That ain't gone. The problem is a lot of that low-hanging fruit has been written, right? If you want to re-implement LS in Rust, okay. But now we're at a scale where things need 50 people. You ain't building Kubernetes by yourself. I know a lot of people say, I can re-implement it this weekend. No, you can't. There's a lot that goes into it. So now these projects are getting bigger. And now the areas that we want to wade into require way more skill sets than most volunteers may have. And so now we're getting to a situation where I think it's an actual net improvement, because 25 years ago, there would be no open source anything. It would have been all proprietary. You would be buying it from Oracle or IBM. Now, by default, companies have to know that no infrastructure project has a chance of success unless it has some semblance of open, right? If it's not available, you may choose something else. So they know that they're also competing. They've been forced into at least trying open governance. Maybe they get wishy-washy because they don't want to give away the farm. Because when I was at Google, when Kubernetes was released, there was a lot of people that were not happy with that decision. Because you're not giving Kubernetes away. You're agreeing to support it forever. If you deprecate Kubernetes in 20 years, people are like, see, that's why I don't trust Google. I knew it. The year is 2050. Can't believe it. I can't trust them. It's like, dude, you got free software for 20 years. For free, you paid nothing for, yeah, but I was expecting at least until my children's die. Like, what SLA are you expecting? Forever. It doesn't work that way. So the way I think about open source is, if a company is bad at open source and they choose to give me the software, but I have to pay for support, that software was a gift. If they release that software under a license that is incompatible with my needs, I can at least study the code, right? That's a gift. If they publish a white paper expressing an idea that I had no exposure to, I consider that a gift. And then if I have a problem with the license, what is the name of your podcast? Fork Around and Find Out. So a lot of people say, hey, I don't like the governance model. We're going to fork it. I was like, oh, go ahead. And then when those GitHub issues start flowing in, people start asking for features. You're like, why does this company think that I want to implement FIPS compliance in LS written in Rust? I don't want to do that. And then you're like, oh, this is bigger than just having an open source project. People expect the SLA. They want stickers to pass around at the conference. Right? They want user groups, SIGs, democracy, code of conduct. Who does all of that? And then this is what the pressure I think that leads to maintainer burnout. So some of the projects that I've seen, even to myself, some of my projects like, I'm done. I'm done. Y'all can do whatever y'all want with it. The fork button is right there. Move your mouse 2 more pixels, that one, click it. It's yours. I've given you the gift. Well, Kelsey, I'm a little upset that you're not maintaining this. Like, you had it for 12 years. Maybe a thank you will be warranted here. So I've experienced that maintainer burnout thing before. And I think what we have to do is understand it's not a marathon, it's a relay. If you're a maintainer, you need to understand what the succession plan is. Who is going to come behind you? Who are you willing to hand that baton to? And the hard thing about this is, does the community trust this other person? So a lot of open source to me is about gaining trust. Do I trust you not to be backdooring my system? Do I trust you not to just take random commits that harm everybody else down the chain? So when I think about open source, it's gotten way more complex than re-implementing Unix utilities in userland. These things are now powering people's entire cloud platforms, their whole businesses, so I understand why it's more complex. But I do think we still have the situation where if you don't like it, you can literally write code. And the only thing I'm a little bit bummed about, like, yeah, when HashiCorp changes the license, that doesn't feel right. As someone who's contributed to HashiCorp, contributed to Terraform, written code to give to the rest of the community, I also have to realize that I wasn't around to maintain it when there were bugs. That was on HashiCorp to do. I dropped my feature off when I was out of there, not my concern. So when they take my code, they're taking on the SLA forever. So when they changed the license, I thought about it, and it's like, man, I didn't sign up for that license. I contributed under that license. And then I reminded myself that I also used that software for 10 years for $0. Fair trade to me. Now, would I not use a software that has that type of license going forward? Probably not. I like alternatives. But I also think that people have to be willing to step up. And to me, open source is about stepping up and creating the future that you want to see. And you can't be demanding that every other company in the world see it the way you see it, because when there's a disagreement, the IDE works for you too. That's just my honest view about open source. I don't think anything has changed. It's just more of it with alternative governance models, and we got to pick and choose the ones we want to support. Those who write the code will decide. What a lively group. I appreciate that.
Okay, who's got it?
Questions is wonderful, so I appreciate you.
Hey, Kelsey. I don't know how. Okay, anyway. So I don't think any of us want to work forever. And you are one of the very few people who remain genuine, and you got out, right? You retired early, and congrats to you for that. If you can go back 10, 15 years, what would you set yourself up, what would you be doing today, right, to set yourself up for an early retirement in this market, in this economy? What would you be doing if you can just tell your 10, 15 or younger self this?
I'm going to stay away from the hypotheticals. Everybody's different. You're unique. You're special in any way. Only thing I'm saying is just one experience point that you can cherry pick something hopefully nice out of it. 15 years ago, maybe like 22 years ago, I had a little computer store outside of Atlanta because I lacked the courage to apply for one of those enterprise corporate jobs. You look at those job descriptions, we need 2 trillion years of Java. And Python and Perl, and we need you to learn Rust even though it hasn't been released for the next 20 years. We need you to know it now. It's like, the hell, this is impossible. And so I looked at those job requirements, I was like, I don't have this. And back then there was college requirements and I didn't go to college. So I was like, you know what, I can't do that. And I was 18 years old. And I was riding around a strip mall. It's like, there's these openings, you can lease it. I was like, man, a computer store on the south side right outside of Atlanta would be amazing because all of them are on the north side of town. So I would go buy parts and set up shop down low, and I used to do service calls. In Atlanta, there's like thunderstorms, like real thunderstorms. And back then, this is like what, 2000? Everybody had those cheap wind modems, you know, like 56K. There's this thing called dial-up. Look on Wikipedia for the young folks. But you used to plug your computer into the phone line, and when the thunderstorm came, they were all destroyed. I already knew what business was going to be like the next day. I was like, yep, I'm all stocked up on 56K wind modems. And so the calls would just come in, hey, my internet's down. I said, yep, it's going to be about 55 bucks. How you know what the problem is? I know what the problem is. And I drive to your house in like 5 minutes, open the computer, stick in the wind modem. Hopefully the drivers don't crash before install because you're going to get a blue screen. You have to reformat their whole system. But then you put the wind modem in. And so I'm doing this for a while, but I wasn't making that much money. I made enough money to have either the computer store or an apartment. So I'm single with no kids, and I have an 86 Jeep Cherokee that I bought from Auto Trader. And sometimes I would sleep behind the shop. Now that I think back about it, why didn't I just sleep in the shop? I just never thought about it. So that I would tell myself, you can sleep inside the thing you're leasing. But sometimes I would just get in my car, and I would just sit in the driver's seat behind the shop so no one can see you from the road. And I would sleep in there and take a shower at a friend's house. And I remember telling myself, I will never be broke again. This is a temporary condition. And in order not to be broke again, I need more skills. And so I said, you know what, I got to find the confidence at some point to not be afraid of those job listings. But the nice thing is I did that business for 4 years, hired a couple people, got contracts with insurance companies. I was starting to make money. And so I was like, but I got to step up to big leagues. And I remember I was like, you know what, Google looks promising. So I worked at Google twice. And so I remember doing this computer business. I'm driving around town. Look, I was making some money, but not that kind of money. And so I remember going to, and I'm using FreeBSD at the time. I'm learning Windows. Back then, you're taking out Novell NetWare and replacing it with Windows Server NT. Shiny. And so I went to the job interview. It was for a data center right outside of Atlanta. And I remember going to this interview, and like FreeBSD is my jam. I'm not really into Linux at the time. And I go, and it's just this trivia. 3 people on the other side of the desk, they're just asking me questions. And I'm like, I'm gonna be honest with you all, I don't know Linux like that. They're like, well, what Unix flavor do you know? And I said, FreeBSD. And I looked down, and one of the interviewers had shorts on. And he had the FreeBSD mascot, Beastie, tattooed on his leg. I was like, oh, yes! And his eyes lit up like a fellow traveler. And he asked me, like, how do you rebuild it? I was like, Macworld. I'm just ninja now. And he was like, you got it. So now I'm working in this data center, and that was the first data center I had ever seen. These things have all this cooling, the service loop, Ethernet split from the fiber. We got scooters riding around because the data centers are so big. SATA array controllers were catching fire because they were cheap, built by Gigabyte at the time. And so I was like, oh, this is how all data centers look. No, that's not how all data centers look. But I realized in 2 months, no knock against the people that worked there, they weren't working as hard as I was when I had the computer shop. People were just standing around the cooler. What are we going to do for lunch? Planning out lunch, go to lunch, come back around 1. Then maybe you might do something before you leave at 4. I was like, oh, my work ethic is my superpower right now. And so I just started getting really good at things. I switched jobs every 3 months because I was in skill acquisition mode. And I got debt-free, became a minimalist, and just started thinking about what's the big picture, because I remember buying a Suburban. I'm only 5'9". And I had a Suburban with no kids, no family. And I had this car because I was trying to impress other people, seriously. And I stopped doing that. So I got my mind right, and I started focusing on the skill set. And at some point, I had a pretty good career. I got to Puppet Labs, from that company, TSYS. I'm in the mix now. And I looked around, I was like, there's not a lot of people old doing this. what's the end game here? And I asked myself, is like, oh man, all these companies want to pay me good money to come and work on these things. And I said, what if I could afford it? Would I buy my own time back? And I did the math. It would take until I was like maybe 65 at that trajectory. And so I started trying to figure out how to go from applying for jobs to people recruiting me specifically by name. It's a different process. When you apply for a job, HR is like, we don't really care who does this. We're just going to interview someone and we're going to get somebody and you're interchangeable, like little robots. Don't really need to know anything about you. Can you process JIRA tickets or not? That's kind of what it boils down to. And so at some point, I remember I started giving talks. Not to be an influencer, that wasn't even the word then. It was more like, I'm working on stuff, here's what I'm working on. And that became a way of building true community in my eyes. But also what I realized was I was interviewing. When I was before I got to Puppet Labs, I was at this company, Thesis, I was using Puppet in production, and they invited me to give a talk in Portland for the very first Puppet Conf. And I went on stage, and I'm doing this live demo, I had this slide deck. It was the most important talk of my life. Because before that, it was just meetups. And I remember Luke Knies, the founder of Puppet, was like, hey, you should come by the office. And I knew the team because I was doing open source contributions, and they knew exactly who I was. No one asked for a resume. I didn't fill out any applications. There was no trivia. They knew who I was. And so before leaving, they gave me a job offer. And it was way more money than I was making before. And I got back to TSYS, and they don't really do the whole open source conference thing. So I'm like the first. My manager at the time, John Christian, he was like, hey, how was it? I was like, it was amazing. And it was dope too, because when I got into this office for the 101, he slipped me this little letter. So back then when you got a little raise out of the blue, they give it to you in a letter. And they teach the managers to slide the letter to you. And you're like, am I getting fired? You're like, wow, how does this work? I've never gotten fired before. Is this how you do it? And I opened the letter, and I got a little meaningful raise. I was like, man, I really appreciate it. But I have news for you. I'm quitting to go work at Puppet Labs. And he told me something that lived forever with me. He was like, I'm surprised you stayed here this long. What you have is special. You know how to ease people's concerns. You know how to gain consensus. You know how to make people believe that there's a better way of doing it. I was like, yeah, I finally have that. And then I decided to do the math on calculation, and it was me being Kelsey is the thing that adds zeros to the negotiation. If they don't know who you are, then you get the pay scale. When they hire you directly, then you decide what the number is. Just how it works. It's not fair, but it's just how it works. And I stopped caring about Jenkins versus Bamboo, Java versus Python. It's literally not important. You have to mature past this dogmatic stance on things. People trying to decide what does cloud native actually mean or not. Why do you care? Solve the problem in the most meaningful way possible. And then that led to, and here's where I wrap things up. I gave this keynote at Google, and there's 30,000 people in the Moscone Center. And if you've ever done work for like a large tech company, they know every word they want you to say needs to go through legal. I was like, I have no script. There's no slide deck, and I can't do a drive run. It's going to be 13 minutes of live demo. I was like, well, what if it breaks? I was like, what if it breaks? It'll be cool. So I do this live demo at GCP Next, and my cursor gets stuck. And I can't copy and paste from Stack Overflow, and eventually it works, and I just said it spontaneously. Good developers copy, great developers paste. And I continue on with the demo. Everyone laughs, and it works beautifully. The CEO of Google Cloud, Diane Green of VMware fame, runs to the back end stage like that was dope. And then Satya from Microsoft reaches out, and he adds a 0. I was like, wow. And Google's like, you shouldn't go there. We will add a 0. And so I stayed, and it cut from 67 to 42. And I retired because I finally had enough money to buy my time back. That's the story. You can clap. Go ahead.
I really liked your comparison at the beginning to sort of physical engineering or like civil engineering. I'm curious if there's anything else that we can learn as software engineers from like bridge builders or road builders or any of the practices that like those types of engineers do.
Standards is one. But the one thing that I've learned from civil engineers is that they build for people specifically. They like take a civil oath. They actually remember who the customer is. There's going to be a real person with a real life driving over this bridge, and if we don't do it right, then they die directly. And so you take it seriously. It's very important. And so I think a lot of people in tech, at least a lot of people I've run into, and me myself at times, we've lost our humanity in some of these situations. We're just doing stuff. You just see things red, yellow, green. Does it scale? But scale to who? Who are you building for? And a number of engineers I meet that have no interest in talking to actual customers. Like, I don't like people. It's like, what the hell are you talking about? You are an actual person. You should at least find a way to like yourself. And then I think you start to understand who you're building for. We're not talking about UX personas that people make up as contrived examples. I'm talking about actual people and how they feel when they use the software. If you've ever built something and you add just the right command line flag, you're like, ooh, this feels nice. You know that feeling, that vibe? That's the thing that you want to recycle and give to other people. And when you get to a point where you're stuck and you can't create that feeling anymore, then we create the prototypes and we show people until we see their eyes light up. And we say, oh, I think we finally got it. We can build things that are delightful. So honestly, who are you building this for? Oh, I work on tax software. It's pretty boring. I hate it. It's a job, though. But go meet an accountant and say, hey, can I watch how you work? And they show you, like, oh, why are you clicking over there? It's like, I don't know. Whoever built this software buried the thing I use every day under 5 different menus. It's like, oh, that was me. What would you like it? And then you really try to understand the actual workflow, and then you do what engineers do. I know how to use the material to create that experience for you. That's what engineering is, literally, figuring out what the thing that needs to be done, and then we find the most efficient way based on the materials available to us to deliver. So if you're like, I think if you're gonna be a strong engineer, you're just trying to understand that problem space so well and the person that's going to use it, and then you apply engineering to it, and if you get it wrong, we try it again until we succeed. So I get why, because HR does not put the humanity stuff on the job description. Most promotion processes do not include the human stuff on the job description. So a lot of us have mistakenly got very far and become senior engineers as junior human beings. And it creates this weird vibe that you can't solve. So literally, seriously, figure out that human part. I know it feels warm and fuzzy because if you pick the wrong programming language, people will just say, I don't like the programming language. If you pick the wrong technology, they can say, I don't like the technology. But when you show up as yourself and they don't like it, I get the fear that they just don't like you. But that's just how this works. Like, you seriously got to go find it. If you're struggling, close the computer, go outside, and then just rediscover who you are. And if it's not where it needs to be, work on that. And that way, when you get back to work, you're a much different person on the whiteboard. You choose when to argue and debate. Am I going to really argue about Python versus Java right now? Is it really that important that we're going to lose a friendship over it? Don't talk to me anymore. You chose Java and I just don't do Java. Don't do that. So that would be my number one advice. If you can figure that part out, that becomes the person where everyone has a story about the person that they love working with the most. I work with this person, they taught me everything I know. But that person also taught you how to be a memorable person. Figure out how to replicate that. I'm going to do a quick time check so we can figure out how much time we have. 20 minutes left. Are we enjoying this so far? All right. We have a question back there.
Hello, my name's Brian Bloomfield, and I actually lived in South Atlanta, so I understand the struggle. And It's really cold or hot, so I imagine that was uncomfortable. But what's the most complex technical issue that you ran into that you couldn't solve? And what was your process to figure out how to solve it?
So when I was joining Puppet Labs, right, this person coming from operations to becoming an engineer, the first thing I did as someone who used Puppet in production, you come from being a customer to now being on the engineering team responsible for building it. So I look at the tool a different way. And so back then, when you wrote configuration management code, it's just files. There's no package manager. You just got to copy files to the right place so that the Puppet command line tool could parse them and just execute stuff. It felt just like writing bash scripts and just running them on the server. So when I got there, there was this idea that what if there was a such thing as like a Puppet module? And Puppet is written in Ruby, and so we wanted to pattern it off of like Ruby gems. So there's this prototype called the Puppet module tool. And it was a separate thing. So when I joined, I was like, hey, this thing should be built in, so that way if you're using Puppet for the first time, you should be able to say, do like a Puppet get Apache, and it will download the Puppet module on the file system in the right place so that you can just use it. Like, wouldn't that be novel? Just like any other software distribution mechanism. But I never written a package manager before. We could have just used Ruby gems. We probably should have, but that's not what you do when you're building up that resume. So we implemented our own package manager. Now, I didn't go to college. This idea of a graph, there's the diamond dependency problem, semantic versioning, and resolving an infinite space of dependencies based on a range of versions. At that moment, I don't know what I don't know. Like, how would you solve it? So naively, you're like, if version is in this range, but then you get so deep in the call stack that Ruby's like, error. You've blown the call stack. I didn't know that was possible. And so you don't even know that there's an algorithm for walking these type of trees. How to visit parts of the graph and never return, because then you hit cycles. But you don't know this vocabulary, so you're just staring at this problem, and you're like, oh my God, I am not supposed to be here. And then you go figure out, is there something on the internet? And these are the type of problems that most people don't really describe in detail. The data structures, the algorithms. This is like a very fringe thing, because there's more people that use things like Ruby gems and RPMs than people who implement package managers. And so at that moment, I'm like a fish out of water, and we missed our deadline. And there was a person on the team, and he said, like, how did you go about solving it? So first, you do everything you know how to do, and then you're at a dead end. There's this magical thing you do. You ready? You ask questions. Like, seriously, you just ask questions. And there's a guy on the team, he was not like the friendliest person in the world, and he's like one of the people like, you don't know how to do that? I was like, no, I don't know how to do that, okay? We have this problem. I'm trying to resolve dependencies and semantic versionings, and this is a very complex problem. And actually, it's not actually an easily solvable problem at all, actually. Apparently, this is like NP hard is not resolvable. The thing is, you just stop at a certain point and say, good enough. Right? And also, it turns out that most people don't actually have conflicts for most of the time. So this is how you can just exit the tree early. So it's like, all right, Peter, please help me and stop schooling me about me not knowing how to do this. And it turns out, Peter doesn't know how to do it either. He got further than I did. He knew we needed a graph. He knew we were walking a tree. He knew that we had to keep track of the nodes we were visiting to build up this dependency graph. What he didn't know about was the diamond problem. There's a part where you get to an unsolvable puzzle. And he kept trying to solve it, but it's not solvable in classic computers. It's not. That's when you stop and say, I cannot resolve these dependencies. You, human, need to take action and try it again. He didn't know when to stop. So we wasted another week and a half, and then we learned about a class of computing problems that are not solvable. So you just try the best time you can with enough memory, enough compute to stop and say, I'm at a stopping point. So we implemented that package manager. We shipped, I think it lives on today, it's called the Puppet Forge. It's like a module store, and you can go and browse modules and bring them down. But that was the hardest problem in my life because I didn't even have the vocabulary to even think through the problem. And this is why I think a lot of software engineering interviews are very hard. A lot of times it feels like hazing, especially if you don't have the vocabulary to even approach the problem. But when you have the vocabulary, these problems feel very easy for a lot of people who's done them before. And I think that's the divide of like, I need to increase my vocabulary proactively. So then I became like a historian. Go read the white papers. You know how they say that you should go read other people's code? You should. If you want to know how to solve things like the diamond problem, go look at the module tool or the module system for Golang. Russ Cox wrote a nice series of blog posts about the diamond problem, why it exists, nice diagrams and graphs. Then you go look at his implementation of how he tried to solve it. And I think that's one way now that I do to be proactive. I'm increasing my vocabulary before I got to write the paragraphs. Right? So that's my hardest problem I've ever had in my career.
Hi, Kelsey. Followed you for many years. Thanks for the Kubernetes hardware stuff. It was pretty cool. So I got a question for you, really. It's a bit of a meta question about where big tech is headed. Where should we all be focusing as up-and-coming people over the next 1, 5, 10 years, and why is it AI?
During my retirement, I do a lot of due diligence work. I advise startups, and I also work with VCs on the whole portfolio, and I do due diligence before they make the investment. 10 out of 10 startups are like, we're doing AI for this thing. And one person came up to me and said, hey, Kelsey, we have AI where you don't need to hire sales reps. I was like, wow, really? He was like, yeah, it's crazy. I was like, I need to see this. I want to be impressed. This will be magic if you can do this. I said, I have one question, though. Have you ever sold anything in your life? He was like, nope. I was like, So there's a lot of naive confidence from people that don't understand the task, that they believe that they can solve it simply. And so he showed it to me. I said, hey, to speed things up, don't say AI, don't say LLMs, do not say agents. Just say software and show me the code so I can see how it's implemented. So you have a sales rep. I've worked with lots of sales reps before. And there's this thing that they do where they go and meet a person, look them in the eye, and establish a relationship. And there's this human bond that's made that then lowers the gates so that we can have a conversation about what their needs are. Once I understand what their needs are, I try to pattern match if I have a solution to sell them. Then we got to work out their budgets and see if this is the right fit for them. And then you go to procurement, which can take 2 years. And then eventually buy the software if you're still working there. I said, so that is my experience in the sales loop. Please show me your software. He's like, okay, so we don't do any of that. What we do is we pull data out of Salesforce and we put into a spreadsheet effectively that you can ask questions about. Who is my best lead? I was like, oh, you're guessing. It's like, yeah, pretty much, but we think that's what sales reps do too. And then if you look under the hood and you say, could you show me the agent? And you say, I just want to see the actual agent. And you look at it, it's like the same utility you would write. You call the Salesforce API, you get data out of Salesforce, and you return it to this thing. And that thing could be an LLM. Okay, it's cool. It could be using the MCP protocol from Minstrel. Gives you like a gRPC-like interface for calling these random tools. Now, there is some value there. Back in the day, we used to have to write these things in very strict order. These LLMs attempt to run a regular expression, if you will. I'm getting this prompt. I see a list of tools. I'm going to try them. It's like you going on a Unix system and listing out all the man pages and reading them all and deciding what's the best tool to call. So if you've never used Unix before, as a natural intelligent being, which you are, you can go on a Unix system and I teach you one thing. There's a thing called man page. And I teach you how to ls binaries in the user bin directory. And you call man on all of those tools, and I tell you from reading all those man pages, which one would you run to list directories? And you would look at them all and you say, oh, I think it's the ls command, right? And so that type of thing is available now. But here's the thing. The computer is still the same. Salesforce is still the same. The inputs and outputs are still the same. The computer didn't change. The tasks are still the same. So when you look at AI as replacing your job, my question to you is, what is your job? Now, There's this thing that I witnessed throughout my career. There are people with 20 years of 1 year experience. They haven't evolved at all. They come into work, they go to Jira, they list all the issues assigned to them, they pull them out, they do the exact same thing every single day. Then they fooled themselves. I have a shell script for it. Watch me run this shell script. I've automated all the tasks. But then why are you still doing them? I do them really fast though. So at this point, you're indistinguishable from modern software practices. And if that's all you're doing, I can definitely program a thing that reads Jira, pulls things out of a custom field, adds them parameters to run the thing, takes the comments, and put them back into the issue. I can totally do that. You are right. I do not need you specifically doing that anymore. So if you found yourself in that part of your career where you're doing something so predictable, so mundane, fortunate news for you, you are in trouble. But that's not the job. The job is to say, why do people keep opening this Jira ticket over and over again? Something is wrong. There has to be a better way. So the goal is not to do the Jira ticket, it's to eliminate the Jira tickets. That is something uniquely human, to make the problem go away in its entirety forever. Abstraction versus automation. So a lot of the LLM AI stuff is automation over the mundane tasks. You still have a bunch of email that you don't want to see in your email box. That system still remains. In this case, the AI may group and categorize the system. Maybe it takes parameters from you to figure out like what you like. Maybe it looks at your address book and makes an inference on what's important and tries to score it, predict that you might want to read it. But that's not the job. You see what I'm saying? So this is why I have no fear of AI, because my job has never to be doing repetitive low-level tasks forever. My job is to try to make those tasks disappear forever. And I'm hyper efficient. I can probably survive on what, $3 of food, 8 hours of sleep. I'm creative. I have an imagination. I have empathy. I'm a whole person. Right? And so I think we have to start thinking of ourselves this way. So I like AI as an augmentation to what we do. AI for programming, if you think about it, the prompt just becomes the programming language. So that's not different than when compilers got introduced to the scene. So I think if you just study back history, we always make these promises that computers will change everything. They tend to create more problems than we started with, and a whole new industry emerges. So my advice to most people is go learn COBOL, go learn C, because once the mess is made with this new set of tools that people don't understand what it's doing, you're going to make a lot of money as someone that knows how the thing actually works. So while they charge by the hour, you get to charge by percentage of GDP. Right? So you're a human, be one.
7 minutes left. Do you want to do a question or want to take another one from the audience? Okay, cool.
You say go be human, and there's all these pressures, you know, in the company, in social, like you said it before, where companies have a slide deck of words you can and can't say, or the user wants, you know, the tax person, the button's over here, why can't it be over here? How do you like keep that humanity? How do you like stay genuine even though you're trying to solve real business problems? Because I find there's a tension there where the business kind of says, oh, be productive at the cost of forgetting who the human is on the other side. How do you like stay genuine there?
The truth is I don't know, and it was a big reason why I retired. Like, I'm just to be honest. At some point, I actually learned trades like drywall, running electrical, pulling permits, and part of that project was like putting in toilets. And I could have called someone to do it, but I just wanted to learn how to do it. And so I went to the plumbing shop, you know, not Home Depot, you go to the plumbing supply store. And you walk in, and they have all the toilets, all the things to fix a toilet, all the tools. And I'm like, oh my God, this is what GitHub must feel like. So I go in there, and a guy asked me my name. I give him my name, and I'm just looking around, and I was like, what's the best thing? You guys, like, if you can afford it, you get this Toto thing, but do not waste your money on this. Get this. I promise you it's the best fit for you. It's like, well, I'm not sure. So I went home and measured all the things to make sure I was going to buy the right thing, watched 7,000 hours of YouTube videos so I can become a plumber through osmosis. And then I go back to the store. And I walk around, and he said, hey, Kelsey, are you ready to get that order now? I was like, how do you know my name? He's like, because I asked you last time. I'm like, why'd you choose to remember it? He's like, that's how we do things. It's a small business. He's not trying to scale globally. He has the one location. He's been working there 35 years. He doesn't have a stock price he's trying to answer to. There's no quarterly business review. His formula is, we stock the things that people use. We're honest, and we help people solve actual problems, and we earn our place in society. I'm like, wow, this is beautiful. But in our space, it's like there's this hunger for monopolies. We want it all or nothing. Think about like how a lot of stocks behave. Hey guys, congratulations. We're making $100 billion in profit. After we pay all the buildings, all the commercials, we still have $100 billion. We don't even know what to do with it. But here's the rub. We need to be growing 20% every year. So now we need 120 billion. And you're like, hey, all of our customers are happy. It's like, I know, but we need 20 more billion. So I need you all to go think about how to find 20 more billion. And you say, I know. We can buy HashiCorp. It's like, oh, yeah, they got Vault. We can triple the price, and we'll get that 20 billion. You're now VP of infrastructure and acquisitions. And then it becomes this unnatural thing, because now the burger place is selling tacos. It's like, but you're not good at tacos. It's like, yeah, but we need to get a little more revenue. And so I feel like this growth by any means mindset is insane. Most things that grow forever die when they grow too fast. Like if you inflate a balloon too much, it pops. And for some reason, I don't know why, people haven't come to the conclusion that there are 9 billion people here. Everyone can have a slice of the pie. You don't need all of it. And so to me, I do like the world where we just take care of our customers. If we're small, we small. But I also do get good reminders. Sometimes I do a lot of public speeches, and I find myself in the middle of Iowa. And there's an insurance company that just takes care of their customers. They're not publicly traded. They're privately owned. They rev share with the employees. You walk around, people are smiling. I've been here for 30 years. They all went to my wedding, the whole team. And I was like, oh, so it still exists. So I remind myself that the hype cycle, the news, just because it makes the front page of Hacker News doesn't mean that's the entire story. So yes, it does suck at the hype layer, but I got a feeling that the majority of things are not that. And so you just got to ask yourself, do you want to create that? And don't be afraid to. Hey, I think that's my time. I really appreciate hanging out with you all.
Thank you. Yeah. Kelsey, you gave me advice when I left Disney to Amazon, and you told me that every company tries to fit you in a box. And that's the job description. You stay in the box. And one thing that I keep remembering is like, I'm not a box. In all of my other interests, the way I kept trying to level up in areas was I kept getting in trouble, and I kept pushing against the edges. And that kept my humanity in a lot of ways, because I'd say like, actually, I do these tickets, but I'm really interested in that thing. I'm gonna go cross that line and go do some things that maybe I shouldn't do. And it got me in trouble over and over again at multiple companies, but it kept me interested, and it kept me getting new ideas on how the humanity and how the product affects broader scope of things. And I think that really plays to like how we grow as people in our jobs and continue to go. And remember, like, your interests are unique, and that's not someone else's interests. And if you keep that going, you're gonna find an edge that no one else is looking at, and you can attack that side of it and keep going with it. So thank you so much for coming. Everyone, thanks for coming. We'll be around. We got lots of talks, so.
Testing, testing. I'll get started here in just a minute. I was just going to wait on the room proctor to come back in. All right. So this is going to be all about my experiences using Gateway API and not using Ingress controller because I didn't have to anymore. So a little bit about me. My name is Gene. I've been doing IT of all different kinds for a long time. A lot of systems administration and DevOps work, but I've also done just about all the other things at some point also. And one of the key ways I approach things is I'm all about using the right tool for the job, whether that be a given operating system or a way of doing something in Kubernetes or whatever it may be. And if you want to find me after this talk, those are some social handles you can get. And on the very last slide of the presentation is where I've got these slides posted online. So if there's anything you want, you'll be able to grab them. You don't have to try and catch things as I show it on the screen, especially if that happens to be too small to read. So a couple years ago when I was here, I saw a presentation about Gateway API. I think it was from somebody at Google talking about this new thing that was coming and was going to replace Ingress and solve all these problems. And I was like, ooh, that's neat. And then I promptly forgot about it until I started working on a new project at work that's actually a greenfield project. And the nice thing about greenfield work is you don't have to be hamstrung by choices you made a few years before when something that at the time was the best way to do it may not be the best way to do it now. And fortunately, I remembered this, and I was like, I should look into that, see what it's all about. Plus, at the company I'm at now, if the project I'm working on or was working on actually goes live, there's a chance it's going to be around for a significant period of time, likely not modified very much. And so using the latest and greatest now means that it will not get crusty quite as fast while it sits there mostly unchanged potentially for a longer period of time. And while working on this, I thought, it's really hard to find any documentation or people talking about Gateway API. And that motivated me to at least take an attempt at doing a presentation on it. So maybe there'd be at least a little bit more documentation or information out there for the next person going down this road. But as things go sometimes, things didn't exactly go as planned. So the project I was working on is still alive, but some of the priorities that I've been tasked with have changed. And so coming into this talk, I had expected to have multiple more months of hands-on experience than I've actually had in the last little bit. As it turns out, I haven't worked on Gateway API in a couple of months, and so I'm a little rusty on some of this stuff. So just ask that everyone bear with me, and feel free to ask questions. I'll have a question time at the end, but I'm also welcome to questions as we go also. But before we talk about the Gateway API, we should probably talk about why I don't just want to use the tried and true Ingress resource. The big thing is it's got a lot of limitations, and it's really aggravating to use. And multiple years of trying to use it, or actually successfully using it, in GKE taught me that I really don't like working with it. It's been just long enough now that I can't give you all the very specific, minute details of why I don't like it, but I remember it being painful. I remember in every chance that I had, I would try and template away most of having to deal with it because it just sucked to deal with and had a lot of repetitive stuff. And I also remember it being very limiting in the fact that it was really, really, really narrowly focused on just HTTP traffic. Not even all the stuff at layer 7, but just pure HTTP. And in the project that I'm working on, I need more than just HTTP traffic, or more than just pure HTTP traffic. I need gRPC. I might need raw TCP and UDP. And I also want to have some of the things that have become a lot more common since the last time I'd worked in Kubernetes, which is things like progressive rollouts and actually using some of the same information or the same resource types while working with a service mesh to get some of the same benefits when I'm working on that side of things. So basically, gateway APIs define a standard way. Well, let me back up. I don't know a better way to phrase it, but the industry around Kubernetes and all the big contributors and players in that market have all seen the same pains that I did with the ingress resource, and they all saw that they were having to configure things by custom extensions. So what you did in Nginx ingress versus what you did in HA proxy, what you did in Coned to any other one. Every single one of them was completely different because they all had to do their bespoke way of doing 90% of the stuff they wanted to do. And everybody knew that sucked, and they decided to do something about it. Take all the pain that they had learned and build a new thing. And that new thing is Gateway API. And so it supports doing both layer 4 and layer 7 stuff, and it supports it in a much more standardized way so that you can take what you know from using one particular version of a gateway and apply the majority of that knowledge to another one. So say moving from Nginx to traffic or to HA proxy or to something else. Instead of it being 100% different like it is with ingresses or 99% different, it should be a lot more transferable knowledge. This table that I snagged off of a blog post from Cone that you probably noticed me referencing a lot, I think really helps break down how the two are different in a way that, at least for my visual brain, helped a lot. Just leave that there for y'all to stare at for a second. But the big thing is that another key aspect is that officially the ingress resource is frozen. There is no more development on it. There are no more changes. There are no more feature enhancements. All the work is going to Gateway API now. So it is stagnant code at this point. So here's the plan for what I had planned on spending my time on, and that I did spend a little bit of time on, just not as much as I'd originally thought. I wanted to use traffic for my ingress, or not for my ingress, but for the perimeter aspect, the thing that would do TOS termination and that would be what people outside the cluster interacted with. I wanted to use Linkerd for traffic inside my cluster, and I wanted to have auto rollouts for a way to do safer deployment of applications and the code that was living in the cluster. And so just to kind of make sure we're all on the same page, I thought I'd break down what a couple of terms that I was using on the last slide were. North-south traffic is basically how someone outside the cluster interacts with something inside your cluster, or how something inside your cluster interacts with stuff on the outside. So the stuff coming and going from the cluster, and east-west traffic is traffic moving around inside your cluster. So one application talking to another, one application talking to the service of another deployment or stuff like that. Pod-to-pod communications also. And then on auto rollouts, the reason I was looking at that is it integrates with Gateway API, and so it takes advantage of the foundational bits from that and ties in nicely with the stack as a whole, which would give the ability to, instead of just saying, okay, it's time to put this new application out, I'm going to put the new one up and tear the old one down all in one fell swoop. Instead, I can bring the new one up in parallel, then route a small amount of traffic to it, then potentially decide that that looks good, and in an automated way, I could start shifting traffic over to the new version. If the core metrics for that application see that stuff's not going right, depending on how I've got it set up, I can either have it just stop the rollout or revert and go back. And so can use data to drive whether or not it's safe to actually put that new version of an application out. And that sounded really, really appealing because I've had plenty of times where new version rolls out, a little bit later, oh crap, we need to get the other one back. This is not working right. Kind of like the idea of not having to deal with that. The reason I was looking at traffic is simply because it seemed to be ubiquitous in pretty much everything that I was reading or watching or listening to as how people were handling the edge today. I know there are use cases for other ones, but every blog post I read, everywhere I went looking for information on how to use Cert Manager or external DNS or application foo, they all seem to have traffic at the edge. And I can take a hint. I was like, okay, this is where there's the most content. This seems to be where a significant number of people are going right now. Its feature set fits what I need. They had, at the time I was looking at it, already fully adopted Gateway API, actually significantly more so than most of the other options I looked at. And it's like, okay, this seems like a good choice. I was looking at Linkerd for a lot of the same reasons. Some of the other service meshes are well known, but they're also meant to do a lot more than just handle that east-west communication. And they're also not nearly as fast, and performance was a very, very big concern for the project that I'm looking at. And the article that's linked there has some graphs that break this down, but basically nobody else held a candle to Linkerd in speed of how fast it interacted and worked. Combine that with the integration with Gateway APIs, like, okay, this seems like a good place to start. Can always try something else if it doesn't, but seemed like a good starting point. So the Gateway API is actually structured a lot different than the way that setting up an ingress has traditionally been done. And it's really broken down into what they call 3 personas, or basically the 3 different types of individuals that are working in or around the cluster as it relates to traffic coming in and out. You've got an infrastructure provider. That could be, if you're doing self-hosted Kubernetes, that could be the team that's responsible for running the cluster. If you're in the cloud, the infrastructure provider is your AWS, Google, Azure, fill in the blank name of other cloud provider. That's that person, and it's the stuff that's really focused at that level. The next down is your cluster operator, and as you can probably gather, it's very easy for the same people to fill more than one of these roles, but it breaks stuff out in a way to where you can have the separation of concerns as it makes sense for your particular deployment. And then in almost all cases that aren't just very small teams doing everything within their team, you've got, separate from the people who run the cluster, you've got application developers who are deploying their applications onto the cluster, and for their application, they're the ones that are going to know which paths need which protocols going to them. So if I'm writing a web application, I know that I need to set up rules for subpath A and subpath B go to these particular backends. And this breaks it out so that that routing information can actually be handled by the application developer and isn't crammed into the exact same Kubernetes resource as the stuff that needs to be managed by the 2 layers above. And that is something that is definitely a unique mental shift from the way Ingresses worked, where everything was crammed into your ingress resource. So going back to this structure, we've got a gateway class at the top, a gateway in the middle, and I do wish they had named those slightly differently because I find it to be rather confusing, but gateway class is at the very edge or very top of the tree. Gateway is where the cluster operator is, and then something route, be it HTTP route or TLS route, is what's down at the application layer. And so this is kind of what a gateway class looks like. It's very simple. This one is referencing a traffic deployment that I had in the cluster. And so I tell it, at the cluster level, I'm telling it that it is referencing the traffic.io/gateway-controller. And that just is the name of that resource over in where I've deployed traffic using their Helm chart. So it's nice and structured, very formal declaration, very easy to drop in a different back-end provider for that part. One step down is we've got a gateway. And so a gateway could serve one application or multiple. In this case, this was a gateway that I had set up just to serve Argo CD. And so I named it Argo CD Server Gateway because that's the thing it was fronting. Threw an annotation on there for the Let's Encrypt cluster issuer for Cert Manager. And under that, we tell it which gateway class it wants to use. It's a gateway class called Traffic-V3, which is the one we were looking at just a second ago. And below that, you just define what kind of listeners. So at the cluster level, I can define, I've still got control at the cluster level of what ports are, effectively what ports are open, what ports we're listening on, and what we can do with those. And I can specify whether the routes to this particular gateway can only be from the same namespace or can be from anywhere in the cluster or from select namespaces. And this is also where we specify some of the which TLS cert to use for the secure ones. So there's multiple kind of routes with the Gateway API, and they're just ways of defining in a flexible way how to get to your application. So as a sample, this is a simple HTTP to HTTPS redirect, and because presentations are done in landscape, I had to take and break this over 2 columns, so the stuff off to the right would be right under the other things. But all this is doing is saying that for the particular host names or the particular FQDNs that are listed in that host name templated block, I want to reference from the gateway that we were just looking at in the section called HTTP, I want to reference that and redirect everything from there to HTTPS, or everything that hits that. So basically everything that comes into port 80, send it to 443. And then there's a second route, so a whole separate resource, to do the HTTPS handling. And the first part of it basically looks the same other than having an S tacked on to a couple places for HTTPS instead of TCP. And in the rules section this time, instead of just redirecting to something else that's at the gateway, we actually start pointing at the application that's deployed in the cluster. And so I have this resource sitting right next to my Argo CD deployment, and it's referencing the service called Argo CD Server that's on port 80, and I'm matching for all the paths. In the path prefix, if I only wanted this particular HTTP resource to work for like a particular subpath, that's all handled right there. But from my experience, this is already easier to reason about once you've done it once or twice than an ingress is, and it's also significantly more flexible without getting into a big mess of YAML that's 3 pages long. So already is a lot easier to work with. So those were all for north-south traffic, stuff coming and going from the cluster. But one of the nice things about Gateway API is that it also works for stuff moving around inside the cluster, so the east-west traffic. And this is the part that, cool, that's actually easier to read than I thought it would be. This is basically the same resource types, but used for east-west traffic. So on the left, we have some kind of HTTP service. And in the parent refs, the key thing that's different here is that instead of referencing a gateway, it's actually referencing a service within the cluster that has the name some HTTP service. And then for the back end, it looks identical. And you can put weightings in there, but basically what this does is it tells it to handle the traffic that's coming and going from that service within the cluster. And these HTTP routes that reference services are paid attention to by Linkerd, by the service mesh, and it actually utilizes them so that instead of sending stuff just directly, it actually uses whatever the information is in these routes to make sure that you've got weighting the way you want it, and that you also get the observability of making sure that it's following the path you want and performing the way you want. On the other side of the slide is an almost identical setup for a gRPC service. And so that would be using a gRPC route instead of an HTTP route. And as you can see, they are basically identical other than the name, which is kind of nice. But they are handled as what they actually are, as either pure HTTP traffic or as gRPC traffic by the service mesh. But the really nice part about this is that it's defined identical as my north-south traffic. I'm not having to do 2 different kinds of resources to basically perform the same function just because it's going a different direction. So one of the other things that's worth mentioning here is this. Your service mesh has to pay attention to these for this to really be useful for you. But because it really does provide a lot more visibility. It's also what provides the flexibility to do things like progressive rollouts, because by having these routes defined, you can then modify them to start routing a percentage of traffic somewhere else, or making a particular replica of an application be more preferred over another. So, as I mentioned, documentation was a little hard to find on a lot of this stuff as I was working on it, and I had a few challenges along the way. So the first is that the Gateway API, unlike Ingress, is not bundled in with Kubernetes itself. You actually have to manage it separately, just like you do a lot of your applications, or most of your applications. And once I got my head around the fact that it's the new normal way of doing it, but that it's not in tree with Kubernetes, that wasn't that hard to deal with, but it was a real surprise for me and threw me for a loop a couple of different times. The other place where that was a little confusing is traffic by default was bundling in the Gateway API. So is Linkerd. You can't have the same CRDs defined in 2 different places. Linkerd had a way of turning that off, and there is now a way to turn it off in traffic also. And traffic is actually working to move theirs. I don't know if it's gotten merged quite yet, but traffic is actually given the option to manage the CRDs in a whole separate chart, which makes it easier for you to manage your version of the Gateway API to be the version you want, as opposed to the one that that particular application decided to bundle in. The other thing that was interesting initially painful, though we found workarounds for it, is because people like Doodle Compute Engine or GKE Doodle Kubernetes Engine and others haven't moved from one of the earlier versions to the V1 of the gRPC route, Linkerd hasn't moved up to that one either because they don't want to break all their customers and all the customers of Buoyant, which is the company that sponsors Linkerd. And I can't fault them for that, but it was a little surprising. They're all things that can be worked around, but it's some of the rough edges from things still being new. While working around with some of the gRPC stuff, I found that there was a couple of bugs in the way gRPC was implemented. It was actually missing a couple of pieces of code that everyone expected to be there. And the issues down at the bottom are just referencing where that was found and is now fixed. But I say that to say that working with the community through both GitHub issues and through the Slack for Linkerd and the Slack, well, not Slack, the forums for traffic was actually a surprisingly good experience. And getting these things fixed is actually something that can be done. And that's one of the advantages of the gateway not being bundled in with Kubernetes is you can get these fixes, get them rolled out, and deploy them without having to wait on whoever your Kubernetes provider is, be it yourself or a cloud provider, rolling up to the next version that happens to have the fix bundled in with it. So in my experience, even though it was a giant pain at a few points, I still think it's worth it, especially considering that Ingress is effectively dead code now and it's not getting any more updates. The Gateway API stuff is easier to reason about once you shift yourself out of the mental map of this is how I've always done it. Once you actually wrap your head around what it's doing, which is not all that difficult, it's just like everything else, especially with Kubernetes, it's just a learning curve that's something you have to deal with. It's actually a lot easier to reason about what's going on, at least to me. It's definitely more flexible, and because of the different integrations it has throughout the whole stack, one thing that was really important to me is it provided a lot more observability about the performance of how traffic's moving around in and out and within my cluster. And that's actually all I've got, but I am happy to take questions. Got one right here. He's going to bring the mic to y'all, so I'm going to be patient while he brings the mic over. He's coming from this side.
Yeah, we do have a live stream, so we want to make sure we get those.
Thank you. Would you say, so I've got experience with Let's Encrypt and Ingress, right, where it's all sort of there. Would you say that Gateway API with Let's Encrypt is easier? So what I noticed there is, and Google's very unclear about where to put the cert piece. They keep saying put all your cert names in the gateway, which invalidates the separation of duties. I noticed, though, in your slides, you've got Let's Encrypt as cluster issuer at that gateway level, but then the route gets to define the name and ask for the cert. Is that still true? Is that?
As of the last time that I worked with it, that is true. And I think the rationale behind that is because the gateway is where the actual listeners are, and that's where it needs to know the FQDNs so that it knows which backend to route stuff to, the SNI aspects of it. I think there's some stuff with that about why you've got to put them in both places. I too found it very odd that I needed to put them in both places, but that did seem to be the case.
But so it looks like cluster issuer, like in the Ingress days, you would define a cluster issuer, let's say as an admin, but then the devs could do the route and FQDNs as they see fit. Is that the case with Gateway as well?
Yes.
Still? Good. Okay.
Yeah, I had my cluster issuer at the gateway level, so at the level that the cluster operator manages. And I had to reference, double check, make sure I'm not saying this wrong. I don't want to tell you the wrong stuff. That's the route.
There we go.
Yeah. So as the cluster operator, as the cluster operator, I still need to know the name associated with the cert that that particular gateway is tied to. So just like this one has the gateway has both the cluster issuer listen under the annotations, and then in the listener section, there's a host name part where you've got to put the name that goes with the cert.
Oh, that's fine, yeah.
But everything related to what happens after the cert, all of that gets handled by the application owner.
So, right, but in like an ingress, right, when I would define my host name and then I would define my cert name, Let's Encrypt would generate everything I needed for me. And I still get the same behavior with Gateway.
Yes, that's still the case here.
Excellent, thank you.
Other questions? All right. And I know you'll be around today and tomorrow, right? So if people have questions to see you in the hallway, that'd be good. So let's give it up for Gene. Okay.
And as promised, if you want to see any of this, that's where you can find it.
Okay. Thank you.
Check, check. Check, 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 check.
Okay.
Introduction, or you just want to go when time starts?
Either way works.
I always find the introductions a little awkward. I don't know. Just like, hey, here's someone. Now let them tell you about yourself. So I'll let you just go for it.
Okay.
So, I'll let you know. I'll close the doors when it's time so we don't get the hallway noise.
microphone is not working currently, correct?
Correct.
Oh,
This
there
is
we are.
working now.
There we are. Okay, good. Got that problem solved. All right, so that's set up. So where did that go? Is the room? Are you the room proctor? Was somebody in here about 10 minutes ago, 15 minutes ago, messing with the sound at all?
In 2 minutes, but we have 2 minutes. Possibly.
Test 1 2, 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 test 1 2. That's speakers. Test 1 2. Test 1 2. Okay, that sounds nice.
Test 1 2.
You sound pretty nice. You might want to move the microphone slightly up, right about there. Go ahead, try now.
Test 1 2. Test 1 2. It's like joining a Zoom call. All the audio settings are wrong every single time. Or you're muted. And they're saying we're living in 2025. Okay.
Test 1, 2, test 1, 2. Is this coming up on the mixer? It's coming up on the mixer. Test 1, 2, nothing.
Okay. All right. All right. Welcome everyone to the Cloud Native track, to the next talk here. So in this talk, I'm gonna tell you some tidbits on how Kubernetes and Linux kernel and kernel versus Userspace tooling always doesn't really play along nicely, let's put it that way. And especially in the kind of intersection between the user space and kernel space and things like that. And of course, some of the lessons, at least we, and by we I mean me, myself and my team, we've been learning. And hopefully you'll learn too, or at least learn what not to do or what to do or things like that. Bit of a warning. So I don't know if you ever read that blog post. It's actually 100% out of context here. It's a kind of a rant on Golang, but there's a very, very nice and fun quote that I've been starting to use every once in a while now, basically saying that everything that we work on is a hot mess, and it's miracle anything works at all. I mean, of course, it's written in a kind of tongue-in-cheek style, but I'm pretty sure that every one of us here has felt that at least at times, if not every single day, but at least at times, right? So the warning is that after the talk, you might actually lean towards that mode of thinking too. Let's see. So I'm Jussi. I work at Mirantis as a senior principal engineer. I've been working with cloud native, containers, Kubernetes, all that stuff, actually well before it was even called cloud native, so that's a while. And I guess you could call me hard-headed because I'm still working with the same things, so I haven't really learned my lessons. As a bit more context for the talk, what I'm doing is actually I'm leading the K0's Kube distro development team, and a lot of the kind of challenges and lessons learned is from that context, because we're working with the Kubernetes distro. Well, Kubernetes, of course, but sometimes even kernel and those sort of things. And unfortunately, whenever you have to work with the kernel things and that low-level things, it's because something is not working. All right, so what I'm going to talk about today is, of course, what I mean by dragons. We're going to have a very, very quick look on what is kind of the kernel space versus user space, what it actually means, and how does Kubernetes relate to all this. We're going to have look at IP tables, IP set, and mod probe as an dragons that we've made familiar in our journey. And then a bit of a summary and QA if there's any questions. I do have a waiver, so I'm not a kernel developer. So what that means is that I might be using some wrong terminology here. So if you are a kernel developer, don't come and slap my face, at least that hard. And I might not be able to answer some of the questions if you go super, super deep into kernel things. But I'm lucky that I have people in my team who are actually doing kernel stuff too, so I'm kind of leaning on their shoulders a bit here. All right, so what I mean by a dragon, in a graphic novels and fantasy fiction, a dragon is usually something, it's actually usually kind of the villain of the story. It comes out from its cave and might actually bite someone's head off. And at least in this case, they might come into your server room and burn it down or bite the head off the network engineer. And as you saw, we are going to go talk about IP tables and stuff, so it's probably the poor network engineer having troubles with the dragon. This one looks somewhat cute, but you know, looks may be deceiving. All right, so in the context of this talk, when we talk about kernel space versus user space, and especially relating to different tooling, like IP tables, for example, of course, as we know, it's the Linux kernel that provides all the needed abstractions for the hardware, for networking, and things like that. So we, as a kind of higher level application developers, we don't really have to worry about, like, okay, how does networking kind of actually work? I mean, we just open a socket to somewhere and send packets, or, well, usually even at that level, you just make an HTTP request from your Python app and boom, you're done. We don't have to care how the networking actually works and how do you talk with the kernel and things like that. And of course, the kernel can be augmented with different modules that you can either compile in or load at runtime to provide additional functionality on the kernel level. Like, for example, netfilter module, which provides the basics of packet filtering and translations. Your friendly firewalls and NAT translations and things like that. And then on the user space, we usually have the tooling to configure things on kernel level. So using IP tables as an example, you run IP tables -a yada 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 to add some rule. The IP tables binary is not really doing anything, right? It's actually just configuring the kernel's netfilter module to have a specific rule. But we'll go actually deeper into that part. But this is the kind of the intersection that I'm gonna talk about today. Like, how does the tools interact with the kernel, and especially in the context of Kubernetes, and unfortunately how things can go wrong, which are usually the best places to learn. And that's how I learned a lot of this stuff, because I had to debug all this. But at least I'm wondering that whether there would be an easier way to learn things than something burning down. Okay, so how does this relate to Kubernetes? Well, like I mentioned, it usually doesn't. I mean, if you're developing your Python Flask application, you don't really care, and you don't have to care about anything like this, right? But of course, in every single cluster, you have a set of system components. And by system components, I mean things like CNIs, CSIs, maybe some GPU operators, and things like that. The basic building blocks that actually makes the clusters usable and enable networking and all these things. Because let's face it, if you don't have a CNI in your cluster, well, it doesn't really work, right? So, for example, CNIs, they might need to manage IP table rules, right? Your network policy controllers, they probably will do IP tables unless you're using something fancier like ePPF. But even in that case, the policy controller will have to talk with the kernel to actually load the ePPF programs. So many of the system components actually interact with the kernel either directly or through these user-space tools like IP tables. Your CSI provider might need to load some new modules, new file system modules into the kernel or something along those lines. All right, let's meet the first dragon. This looks not so cute anymore. And you probably guessed the name of that dragon already. So, and I've personally always feared to work with IP tables. I can't remember the times that I've actually been able to block myself while doing IP tables. And I'm pretty sure some of you have done the same. So, like I mentioned, IP tables as a tool, as the binary that you call from your terminal, it's a user-space tool, and it actually kind of manages the rules in the kernel level. IP tables as a tool can actually manage two different types of rules as kind of like a back-end rules, the legacy IP tables or the newer NF table rules. I'm not going to go too deep into what's the difference between legacy or NF tables. It doesn't really matter in this context. And like mentioned, in the Kubernetes cluster, there's a lot of components that can actually talk with IP tables. kubeproxy does IP table rules, your CNI provider does it, your network policy controller probably does it. So the list goes on and on. And they are a pre-containers era tool, which means that IP tables is really designed in a way that there's only one IP tables in the system, right? The one provided by the operating system. The different modes. So when you do IP tables from command line, like IP tables, you add a rule for kube firewall, yada, 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 it might actually end up in either legacy or the NF tables rule set. So you as a user, you don't really have to know where it actually goes, whether it's executed by the NF tables or the legacy IP tables. The selection of where it actually goes and where it's executed, it's actually configured on the operating system level. And how it's done, it's usually done by having the IP tables binary symlinked into the correct mode binary. So when you call IP tables, it's actually a symlink either to the legacy X tables or to the newer NF tables binary. But you can still do the same IP tables commands without you having to worry that, okay, whether this is legacy or NF tables mode. So there's sort of I don't know whether that can be called a translation, but something along those lines. This is taken from Ubuntu 2022.04. Your operating system configuration might be slightly different, but I think in pretty much all of the cases it's done by these symlinks. That brings us to lesson 1. learned, of course, the hard way. We need to make sure that every single component talking with IP tables are actually using the exact same mode. If I have, let's say, kubeproxy talking the legacy mode, and then my host system's firewall is actually talking NF tables, voila, I have different sets of rules in different backends, and let me tell you, the outcome will be very, very undefined. Probably meaning your networking is more or less broken. Luckily, in the community, we have these IP tables wrappers, helper, tool, thingy. Let's call it a thingy, for a lack of a better word. So basically the whole idea of the IP tables wrapper is in your containers, or you could actually put it on a host side too if you want. It's actually a wrapper for IP tables. So instead of IP tables, you actually call this wrapper. And the wrapper has logic in it to detect that, okay, whether I should be using the legacy mode or NF tables mode, and then it actually is able to swap itself or the symlinks into the correct mode. So basically, kind of, if you have all your networking components using the wrapper, it kind of forces every one of those to use the exact same mode. I think it looks for the existing rules on the system before the first run, and then figures out that, okay, there's like 0 rules on legacy mode, but X number of rules on NF tables mode, so we should be probably using NF tables mode, or vice versa, or something like that. I don't remember the code by heart, so. It's a very good thing, and if you're working with networking components, make sure your containers and your components are using that. Unfortunately, it's not bulletproof. We've seen cases where it fails and still 2 different components are talking with 2 different modes and things go sideways. So you might need to force some components still in some cases, but I'd say that it usually works, at least. All right. Versions of things. So remember when we talked about this triangle thingy on the user space versus kernel space, and the IP tables as a tool, it doesn't really do anything other than talk with the kernel to insert or manage the sets of rules. The rules are really stored on the kernel level, so the IP tables is really not doing anything. And now when we run different containers and different components in containers and in pods, like CNIs, network policy controllers and whatnot, voila, we suddenly have multiple instances of IP tables used on the same system. And what we found out is that different versions of IP tables can actually interpret the rules from the kernel differently. And that's where the fun begins. Or fun. Let's take a bit of a sidestep. How do we manage the IP table rules? So let's say that we're running a network policy controller using IP tables as the way to block the traffic. For the legacy IP tables, there's no practical way to manage individual rules. So you cannot go and tell that, okay, remove the rule number 11 on the system. It's not like IP tables in the kernel, it's not like a transactional database or anything, where you can identify that, okay, let's remove this one row only. So basically what it means is that managing rules means that the network policy controller, as an example, it has to actually read all the rules, do the changes, and then write everything back. Which means that IP tables is not probably the best alternative anyways for huge clusters. Okay, so why do versions matter? Let's assume that I have a component running with 188 version of IP tables, and I had a rule that basically says that the rule name is kube firewall. There's some comments, and it matches all the packets that are marked with that bit set. And if it sees a packet with that bit set, it'll drop it, right? Okay. Seems like a neat helper rule. I just have to mark a packet, and then something else in the chain will actually drop it or do something for it. That's cool. Then I have another component in the cluster running with version 187, so just one patch release lower. It reads all the rules, does its changes, and writes everything back. Notice there's a small change in the rule. I see some people smiling, so I guess you figure out already what happens. So for those who are not that familiar with IP table rules, it's missing the mark part. So what it means that it'll drop every single packet. And in this case, because it's a kube firewall helper kind of rule written by kubelet, it actually happens to be like one of the very, very first rules in the IP table rule list. So, yes, every single packet is dropped. That was fun to debug. Because you cannot even SSH into the nodes anymore. They are bricked, more or less. I don't know who had a video of me when we actually stumbled on this. So this was basically me and my whole team when we were figuring out what the hell is going on. Of course, when we finally figured out that, okay, what's going on, because for us, things were just like, okay, networking worked completely. We have no idea what's going on. When we finally figured out what is actually going on, we of course reached out to the NetFilter folks, who are the maintainers of IP tables and the whole NetFilter kernel modules. And we were like, this gotta be a bug somewhere, right? I mean, if they interpret the rules differently, it has to be a bug. Well, there's a fine line between bug and a feature, like we all know. Phil, he's one of the NetFilter core developers. He basically said this in the Bugzilla issue. But there's no guarantees of anything between the versions. And we were like, okay, this is going to be interesting. Which, if we think about it, it actually kind of makes sense in a way. I mean, of course, not our point of view, we were crying on the floor, but from their point of view, it actually makes sense. The whole NetFilter IP tables, it is really a pre-container era tool. It hasn't been designed in a way that you should have multiple different instances of it running on your system, right? Because if we think about it, it's born in an age like, I don't know how long ago, 15, 20 years ago, where you had your operating system and it bundled IP tables for you, and that's it. So that brings us to lesson 2, and probably the most important lesson. We need to ensure that every single component dealing with networking, dealing with IP tables, is now not only using the same mode, but it has to have the same version. Otherwise, things might or might not work. That includes your host, if your host is using IP tables as a firewall mechanism, kube proxy, CNI provider, network policy controllers, if your mesh is using IP tables for anything, or whatever networking component you're using. Can we really pin the IP tables in all the different components? Depends how your clusters are set up. In the K0's Cube distro, this was the point in time when we actually started to do things a bit differently. So what we actually do is and of course K0's, if you don't know it, it's fully open source, and we're on our way to becoming a CNCF sandbox project too. So what we started to do is we actually embed IP tables within the K0's binary itself, so that kubelet will actually use our version of IP tables. And we pin all the system components, CNI providers, network policy controllers, we pin them to use the exact same version. So now at least all the components we control are using same mode and same version. Of course, we can go and override what's on your host operating system. So there might still be slight discrepancies there. But at least we try to make the world a better place in that sense. Of course, we as a community around Kubernetes, there is a certain trend of moving away, at least from the kind of legacy IP tables mode and from IP tables in general. Like I mentioned, it's really not the best mode anyways, because of this read all, modify, write back thingy. And it's also slower than the NF tables mode. And one of the really nice things in NF tables is the fact that in NF tables you can actually go and modify a single rule without doing this kind of read all, write back type of a transaction. And of course, as we've all probably seen, there's a lot of the networking components are now embracing eBPF too. But in eBPF, they still have to talk with kernel. They have to load the eBPF programs into the kernel. I have no idea whether there's dragons in there. I haven't really been in that space at all. But at least it's supposed to be a lot faster. All right. Next dragon, IP set. Anyone know or been working with IPsec know what it is, what it does? Okay. IPsec is basically a tool kind of similar-ish to IP tables. So IPsec really allows you to manage sets of addresses in the kernel. So you could say that okay, I have a set of addresses for my service endpoints, for example. What it allows you to do is use those sets of addresses for super quick lookups, for example, in IP table rules. So instead of having a rule that says that, okay, if we match this IP, then it goes to this endpoint, or the other endpoint, or this third endpoint, and so on, you could actually say that, okay, if we match this rule, then it goes to this set of things. They're stored in the kernel in the kernel memory as like hashes and bitmaps and whatnot, as super quick lookups. And it's another pre-container era tool. You might already know where I'm going with this. Okay, versions again. We have multiple networking components in the cluster, which all of them, they don't use IPsets, but some of them do. And those components are running on pods, on containers, which means that they have to have IPsec bundled in the container image. And again, do we know which version they are using? 6.2 kernel itself added a new bitmask parameter for IPsec. So when we cross the kind of boundary from user space to kernel space with IPsec commands, there's a new option in there for the bitmask. And some of the older IPsec versions just cannot cope with that anymore. So now there's like a third item in the matrix of versions, or second, depends how you think about it. So not only does the version of IPsec matter, the kernel version also matters to make things even worse for us. So you might actually get some errors in your networking components about the incompatibility between the kernel and user space. And those are the kind of errors that you don't see daily. So it took a lot of reading of kernel sources and all that to figure out what's going on. So, lesson 3, we need to pin the versions of IPsec across all the networking components that are using IPsec. Queue proxies, your CNI providers, mesh, network policy controllers, whatnot. Again, in K0s, we started to pin the version of not only IP tables now, but also IPsec in all the networking related components that we kind of ship with the distro. But that still leaves the host outside. So whether your host tooling, firewalls, whatnot, if those use IPsec, it's like all bets are off type of a thing. It probably works, but it might not. And the kind of nasty part of this is that you can really trigger these version incompatibilities in a very, very surprising way. For your IP set, because it also kind of depends on a kernel version. You just upgrade your OS to newer kernel, and boom, something is broken. Or you upgrade your operating system packages to newer version, and boom, something is broken. So that's the ugly part of it, unfortunately. All right, third dragon, mod probe. And if you haven't figured out already, these are AI generated or AI generated. I can't throw anything. Mod probe as a tool, it's again a tool that kind of crosses the boundary between the user space and kernel space. It is a user space tool that you use to load or unload the kernel modules. And it has to cross the boundary because we're telling the kernel that to actually load a new module. The nice thing in mod probe is that it handles dependencies. So let's say I want to load a module called foo, which depends on another module called bar, and mod probe is able to figure it out and then basically load both modules for me. And like I said, it does interact with the kernel. So the kernel modules are these kernel objects .ko files, and they are pretty much always distributed as somehow compressed on with your operating system. So basically in your operating system you see, if you look like /lib/modules, yada yada yada, you see a lot of these ko files or ko.gc or xc or something. What the mod probe tool itself does, it basically uncompresses the modules before the kernel can actually load it. So the kernel doesn't really want to have anything compressed. It wants to have the plain object file. So the mod probe tooling actually has to decompress it. How does this relate to Kubernetes? Well, again, usually it doesn't. Again, if you're writing your Python application, you don't really load any modules, or at least typically you don't load any modules. But again, some of the system components actually might need to load modules. Your CNI provider might have to load some contracts or other networking modules. Your CSI provider might need to load some file system support. Your GPU, if you're doing ML AI stuff, your GPU operator definitely needs to load some kernel stuff, and so on. And how do we do that from the cluster, from the pods? We of course have to do host mounts. We mount the libsys, whatever needed directories from the host to the pods, and then run mod probe in the pods. And I guess it's safe to say that mod probe is again a pre-containers era tool. And by now I'm sure you'll figure out what that means. And no, it's not about versions this time. Sort of, at least. So, what's the problem? The problem is that your operating system is providing the modules. They are, like I said, they are pretty much always compressed with some algorithm. But what algorithms does the mod probe support? Because now the mod probe is running actually in a container, right? Let's say that, for example, we're a CNI and my CNI is loading some contract modules or something. I'm doing that from a pod, from a container. So what does the mod probe that I'm executing in the container, what compression algorithms does that support? So for example, the DPN12 base image or the K-mod probe that you get with that supports ZSTD and XZ algorithms. But my host ships with GC compressed modules. No loading modules for me. So yeah. Sorry.
All right. Are there CNIs that load modules?
Yes.
That sounds scary.
I can't remember whether it was QProuter or Calico or... No, wait a minute. Oh. I can't remember which component. It definitely was a networking component. But I have three options: QProxy, Calico, or QProuter. It's either of those, one of those three. I'm leaning towards QProxy actually, but I don't remember 100% sure which one it was. But it definitely was a problem that I remember. So yeah, if you have to deal with kernel module loading from your kind of application system component point of view, it's a thing that you have to keep an eye out. Okay, enough about dragons. So I want to kind of give a bit of insights how we were able to debug these sort of things, because like in the IP tables example, or not example, in the case of IP table troubles, you really lost all networking. So debugging in that case is like, how do you do it? You can't SSH into the node anymore. You can't do anything. You can't have like PNCs or anything anymore. The only way basically you have if you have like a serial terminal, which we didn't. And for us, because I'm working on a Kube distro, so this didn't happen for us in production. So that's the good part. It did happen on CI, where basically suddenly all CI is red. And it was like, okay, something is going wrong. The errors that we saw, like for example in the IPset case, they are very, very unfamiliar, unless you're like super deep, hardcore kernel netfilter developer. And we're dealing with super low-level things from like traditional Kubernetes application point of view. So it was a bit of a hard time for us. Our CI is built from day one actually to run in containers. So we actually spin up in our CI Kubernetes clusters in containers, which meant for us that we can actually run the clusters and debug things locally. And even if all the networking breaks, we can still Docker exec into the containers and actually see what's going on. So basically what we ended up doing is doing helper scripts that do like timestamped dumps of IP tables and networking configurations and networking states and all that. And after a lot of trial and error, we were able to figure out that the rule is this, now it's this. Something happened in between. And we did have to read kernel netfilter code a lot, which is painful, unless you're really familiar with low-level C and that stuff, which I'm definitely not. Bit of a summary. IP tables, IP set mode probe, the three dragons we faced in our journey. They are pre-container era tools, which means that they are not really designed in a way that you run multiple instances of those across your system. Both IP tables and IP set can be picky on the versions used. So you really need to try to ensure that you have only a single version in use across all your different networking components. Or use K0s as your kube distro, because we do it for you. And test everything before rolling out to production. And by everything, I really mean everything. Because we have multiple different networking components in play. Kernel version plays a role, your host configuration, your host IP tables version, your host IP set version. They all play a role in this networking stack. So you really have to test the specific combination that you're going to use in production before production. Because changing one version somewhere might actually break something else, and it can be very, very difficult to debug. Why did all my networking break? Back to my favorite quote. Computers, operating systems, networks are a hot mess. How many agree with this now? See a couple of hands. Yeah. I mean, again, it's really jokingly written, and I'm interpreting and using it very, very jokingly, but there are days that I agree with this. Thank you. And I'm happy to try to answer any questions you have.
Yeah, you talked about these tools, which, as you say, they are pre-container tools. So it makes me wonder if there's a push right now to move, maybe move some stuff to the user space, or maybe develop better tools which don't have this fundamentally problems when we cross into container space.
At least in the scope of Kubernetes, there is. So like I mentioned, there's a move kind of away from the legacy mode tables anyways. And for example, kubeproxy now has, I think it became GA in the last release, I think, the NF tables mode for kubeproxy. And if I remember correctly, it's actually not even using the NF tables binaries or anything anymore. I think it talks directly to the kernel using netlink socket. I might be wrong on that, but at least it's going into that direction that yeah, let's kind of skip the user space tools and talk directly to the kernel through netlink. But you know, that has its own challenges. And then again, I think for us developers, you have an IP tables or NF tables binary, which is kind of super easy to use. So should my code just call that, or should I need to actually start figuring out how do I talk to kernel through netlink sockets and all that stuff, which is very, very complex. So, I mean, I think there is a kind of direction going that way, but it's not super fast, unfortunately.
Hi. So some of I think you were dynamically installing some components, and there is a mismatch of expectations in that. For instance, you're installing kernel modules which are compressed in a particular way, but so one way is to figure out in the kernel config if that is already supported. So do you think it's useful to have a capability to check, measure twice, cut once? I mean, before actually trying it, it'll check. Just like in RPMs, you have requires. Is that missing here in the general system? So before we randomly, dynamically change the system, it checks if it is supported before trying it and failing, and then we look at the logs to find out why it failed.
Yeah, but in this case, I mean, I think most components actually do it that way, but it doesn't really help us all, help at all, because you still have a somewhat failing component because it doesn't have the module it needs to work, right? So it doesn't really help at all, but even if it checks that, okay, should I even load this module or not? Because it's still probably going to fail because of different compressions and whatnot. So, I mean, yeah, of course it makes sense to check, but it doesn't really help at all, unfortunately, if we hit that case. We haven't hit that case too many times, luckily, but few times.
Yeah, I was wondering to what extent with the like the more premium CNI providers like Cilium, would you more likely avoid these types of compatibility issues? Partially because the vendor already kind of vets a lot of this stuff, but also because eBPF is kind of a different interface than what these user land tools provide.
I'm pretty sure with eBPF you get away from like pretty much all of this, at least if not all. So I think that's a safer route in that point of view. Whether I like eBPF, that's a different discussion.
So you mentioned that the IP tables rules and the IP set addresses, like that's a kernel thing. The kernel does everything. The Userspace tools just set that up. Does that mean that's compiled into the kernel, or is it just like a config file that the kernel reads at boot up, like the fstab? Do you need to recompile? I guess.
No, you don't. No. So IP tables rules and IP sets, they are managed in kernel in memory. So it's basically a rule set and set of structures in memory that the kernel then uses to filter packets on and stuff like that.
Right, but when does that get populated? At boot up? Like, is it read in through a file?
No.
How does it get populated?
So the net filter and kernel itself, it's kind of like stateless in a way that when you boot up the node, it doesn't have any rules or anything. So something has to load up all the rules in. Typically, if you have a host firewall, you have UFW or something to manage the firewall, it actually has hooks into the system boot up to load things, to populate the in-memory kernel state.
So your use cases were, except for the mod probe, they were all network related. Like I run into these kinds of problems like ABI, when I'm just compiling programs, it's just like, it's terrible. You know, just like the dependencies on, you know, glibc, systemd, the Linux kernel, like everything breaks all the time. So, I mean, it's not just networking is what I'm getting at. It's like everything's always broken.
Absolutely. All my examples, or most my examples, are from networking point of view because that's the most common place where we've seen the dragons, and which are the most, how to say, nasty ones. Because if your production networking goes down, then
this is maybe controversial at a Linux conference, but I'm wondering if you see a future where we have a like cloud native kernel that we're running on that's maybe designed explicitly to sort of support Kubernetes, and we're not really using Linux, or maybe we're using a Linux fork or something like that that gets rid of some of these more legacy tools and operations. Does that seem feasible to you?
That's a bloody good question. I have actually thought about it, but I don't have a good answer for that. But I mean, I see the technical kind of, from pure technical point of view, and of course this is now my very, very personal opinion. The pure technical side of it, yes, I think it makes sense. But then, I bet a lot of your companies that you work on, you have connections and deals with people like Red Hat, and you use our Red Hat Linux, and you use this, or you use canonical subscriptions or whatnot. So there's always that side of conversation too. So I mean, to answer your question from pure technical point of view, I think it kind of makes sense. Would it fly in a bigger scale? Maybe not.
Makes sense, thank you.
Have you seen or considered from the networking point of view the container runtimes which are running lightweight VMs instead of containers, which are getting popular recently? Because it is a different networking, right? It's now hypervisor networking, which probably has its own dragons, but it wouldn't have the kernel interaction in this case.
It would actually have the same problems. Because even if you run your pods in VMs through, let's say you use Kata containers or something has to set up the networking for the VM, right? Which is something on the host side. Your CNI would actually still have to set up the interfaces that are mounted into the VMs. So you would actually hit most of the same problems.
Thank you, everyone, for coming. I think we're at time.
All right.
You'll be around?
Thanks. And I'm going to hang around if you want to have a chat or something.
Test 1, 2.
I think you're still using that. In a lot of rooms are using that. Test 1, 2. Full battery. Check 1, 2. Check.
Hello? Oh, I see. Okay.
So hold on.
Hello. Okay. Yeah, this should be. Ah, okay. Perfect.
Yeah, something, I know, it's like weird.
Okay, I think this needs to be over the top of your hair, actually.
Oh, does it? Oh,
Yeah,
okay.
well, just the problem is that your hair is pointing down. Like I said,
Oh.
the person who designed these
Has no hair.
Yep, there you go.
Yeehaw.
Is that going to stay on? That's the question. Do you feel like it's going to stay on?
It feels like it's going to slip off the side.
Oh, it's not on your ear.
Yeah, I know. Yeah. Oh, okay. I see. I see. Yeah. I've never had trouble with these before. Yeah. Yeah, I've done tons of these with the mask on, so I'm not
Okay, yeah.
I'm not particularly worried about that.
So if you're going to wander around, you should clip this on.
Yes, I will wander around.
Doop, doop.
All the things in all the pockets. How do you hate me? Okay. Okay. It's in. It's in.
And then we need to plug in video.
Oh yeah, where's I think the HDMI is on this
Yeah,
side.
so
Yeah.
they-
I don't need
Okay,
the
go for it then.
the adapter because it's direct. Oh my god. Okay. I swear I've done this before.
Deep, deep.
Oh look, you see my other screen. Cool. Is that full screen? There. Ta-da! Yay.
Layla or Villela?
Villela.
Villela.
Yeah.
Villela. Okay.
Testing. Okay. This thing's not in my face anymore.
Okay, so you don't mind, I'm going to go out
Testing.
in the hallway and shout at people.
Okay.
And then I'll be back in.
Thank you. I hope I don't tip over.
Okay, we'll get started in about 2 to 3 minutes. People are still getting back from lunch. Hello, everybody. Welcome to the afternoon, a Cloud Native Day. I am pleased to welcome here Adriana Villela and Reese Lee, both of whom are contributors to the OpenTelemetry project and very experienced in Kubernetes observability. I think this is your first time presenting at SCaLE?
Yes, it is.
So their first time presenting at SCaLE, so welcome to SCaLE.
Thank you.
And they are going to explain how to troubleshoot the OTel operator. So welcome.
Thank you.
Thanks so much.
Oh. Thank you all for being here.
Yeah, we're very excited. Well, before we get started, and thank goodness the rain clouds parted from yesterday and it's a nice sunny day out. So yeah, before we get started, we are going to introduce ourselves. My name is Adriana Vilela, and I am a CNCF ambassador. I was a HashiCorp ambassador for 3 years. I'm also a blogger, podcaster. I'm an O'Reilly author. I have an OTel video course on observability. I do have a day job. Most of my work entails working with the OpenTelemetry community. I'm one of the maintainers of the OTel end user SIG alongside Reese. And by day, I work as a principal developer advocate at Dynatrace. And by night, I like to climb rocks, and I'm hoping to check out one of the local climbing gyms here tomorrow. I also love capybaras. They make me happy, and why not enjoy things that make you happy?
Thank you, Adriana. I'm Reese. I am a senior developer relations engineer at New Relic by day. I also work, as Adriana mentioned, alongside her as a maintainer on the end user SIG and the OpenTelemetry community. Two of the things that we are focused on the end user SIG is driving adoption and implementation through creating resources specifically for end users. We also act as a liaison between the project SIGs and end users to drive priorities and help improve the project overall. And I also enjoy gardening, jujitsu, horror movies, and you can find me on CNCF Slack or LinkedIn. I'm trying to get on Blue Sky, but it's...
Come on, you can do it.
I just got onto X, and now it's like gone, so... Okay, so here's how we have organized our session for you today. We are going to start with a high-level overview of the OpenTelemetry operator. We're going to get into how to install it, how to deploy the collector using the operator, and we'll also talk about how to inject auto-instrumentation into Kubernetes pods using the operator. And along with those 3 sections, we'll also talk about some common issues as well as how to troubleshoot them as we go. And then finally, we'll wrap up with a summary, and we'll also have references at the end for you, and you'll be able to access this slide deck as well because we have some, a lot of tips and tricks for you, as well as code snippets and commands that you can just copy and paste. All right. So, what exactly is the operator, and what does it do? So if you have an application running on Kubernetes and you're looking to use OpenTelemetry to gain insight into the health and performance of your application and cluster, you might be interested in the OpenTelemetry operator. So it's responsible primarily for 2 tasks. The first is to manage the deployment of your collector and make sure the configuration is correct in your cluster. It also manages configurations across a fleet of collectors using a network protocol called OpAmp, which is a remote protocol, network protocol for remotely managing large fleets of data collection agents. The second primary task is to inject and manage auto-instrumentation into your Kubernetes pods, which Adriana will go into more in depth shortly. Okay. So how do we install it, and what are some common issues, and how do we resolve them? So this might seem obvious, but before you install the operator, you must have a Kubernetes cluster you can install it onto, preferably one that is running on at least version 1.23. You can spin up a cluster on your machine using a local tool such as Minikube, Kind, KOS, or of course use a cluster running on a cloud provider service. Next, and this is less obvious, if you are going to use Cert Manager, which is a component that manages Kubernetes certs for you and make sure they're valid and up to date, you have to have it installed on your cluster before you install the operator, or else it will fail. If you don't want to use Cert Manager, you can get around that by provisioning the TLS certs in the right places. And finally, to install both the Cert Manager and the operator, you can do so via either kubectl, I don't know, I think there's like different pronunciations that people use. I usually use kubectl. I know some people say kubectl, kubecontrol. And so you can either use that or a Helm chart. And we've included the commands for both, as we mentioned in the following slides for your reference. So to install Start Manager and then the operator using kubectl, you can run these commands. And if you're going to use Helm, note that you need at least version 3.9 of Helm. And this step will take up to a few minutes, but once that is done, you can now install the operator, which, oh, yes, that was saying version 3.9. Okay, using these commands. So know that in either case, you're going to have to wait for Start Manager to finish installing before you install the operator. Otherwise, the operator installation will fail. Yes, in order. Okay, so once you have Start Manager and the operator, or if you're using TLS provisions, then have that set up, you can now deploy the collector. So how many people here have used OpenTelemetry? Show of hands. Okay, almost everybody. So it sounds like you all might be familiar-ish with the collector. Okay, I'm getting a vehement head shake. Okay, this is good. Okay, so the collector, it's a pretty essential component of OpenTelemetry. If you're just using OpenTelemetry for testing purposes, or you're in the beginning stages and you want to just kind of check it out, you don't necessarily need to set up the collector. You can set it up so that the data collected by your SDK goes directly to your back end, and that's a quick way to get set up and test how things are going. But for anything kind of more than that, you will want to stand up a collector. And so we're going to talk a little bit more about this now. So the collector is a really cool vendor-neutral component. It ingests data from a variety of sources. It transforms that data in a huge number of ways. And then finally, it exports that data onto one or more observability backends of your choice. It also is supported by connectors and extensions. Extensions don't access telemetry. They're more for like checking the health status of your collector and stuff like that. I shouldn't say stuff like that so much. But we're not going to get into that, so don't worry about it. So yes, the collector is pretty cool. We have actually other resources that I think we have included them at the end of the slide deck. But yeah, the collector is pretty neat, and there's a lot of stuff you can do with your data. I think it has a large number of components. So yeah, receivers are how you get data into the collector. Processors, which you can use to scrub PII. You can do tail sampling. You can batch your spans. So it's pretty cool. And let's see. Okay, so the operator has a custom resource for managing the deployment of the collector called OpenTelemetry Collector. So here is a sample custom resource for the collector, and we want to point out a few things. So first, note that the version here is v1 beta 1, and why this matters will soon be revealed, and the kind is OpenTelemetry Collector. And then depending on how you plan on instantiating it, there are many config options for this resource, but the basic config requires two things. First is the mode attribute, which needs to be one of either daemon set, deployment, stateful set, or sidecar. And here we have the example set to stateful set. If you leave it blank, it will default to deployment. The second thing is the config attribute, which contains the configuration of the collector as its value. One more thing we want to call out is that if you specify the mode as sidecar, there are some additional things you'll need to do, which we will cover as we go. So in this example, you'll need to add an annotation to your deployment YAML, which we've highlighted here for your reference. So what happens when you deploy the OpenTelemetry collector, custom resource, and things go sideways or they don't go anywhere at all and you're not seeing any data? So let's take a look at some troubleshooting tips. First off, one of the first things you can do is check your Kubernetes events. Kubernetes events provide detailed chronological information about what's happening within various components of your Kubernetes cluster. And to view events for a specific namespace, you would use something like this. Of course, replacing namespace with the actual namespace of where your operator and resource are deployed. Another thing to do is check whether your resources were successfully deployed. When an OpenTelemetry collector resource is deployed, the following objects are created. So you have the OpenTelemetry collector, the actual collector pod, and depending on if you've specified deployment daemon set or stateful set, you would look for a resource with the following name format, or if you've specified sidecar, then you would look for a collector sidecar container to be created in an app pod named OTC container. Another thing you want to look for is a config map of your collector configurations. If you have specified sidecar mode, you want to look for something called, So if you specify the mode as sidecar, the collector config is actually included as an environment variable. And finally, if you have enabled the target allocator, you will look for a target allocator pod to have been created as well. So when you deploy the OpenTelemetry collector resource, make sure that these objects were created. First, check that the collector resource itself was deployed. Confirm that your config maps were created. And we also recommend checking your collector pods, and depending on the mode you specified, you can use the appropriate command. So again, sidecar mode has its own special command. Another thing to do is to check the collector CR version that you're using. So earlier, I talked about the custom resource using the V1 Beta 1 version. There is another version, V1 Alpha 1, and there are two main differences between these two versions. So the config sections are different. For V1 Beta 1, which is the one that we saw earlier, the config values are key value pairs that are part of the custom resource configuration, whereas for V1 Alpha 1, the config value is actually one long text string. Keep in mind that the text string still needs to follow valid YAML formatting. Also, if you're using V1 Beta 1, you can't leave the collector config values empty. So for scalar values, you have to use empty curly braces, and for arrays, use brackets. This isn't necessary if you're using V1 Alpha 1. So kind of some little details to keep in mind. Another thing you can do is to check the collector base image. By default, the OpenTelemetry collector CR uses the core distribution of the collector, which is a bare bones distribution of the collector and contains just the base set of receivers, processors, and exporters. If you want access to more components than that, you can absolutely use the Kubernetes distribution of the collector, actually. This distribution was made specifically to be used in a Kubernetes cluster and contains a subset of components from the core and the contrib distributions. You can also build your own collector distribution as well. There's a tool called the Collector Builder.
Yeah, it's
Custom
the OCB,
OCB.
Open Telemetry Collector Builder.
Yes. I hear it's actually not too hard to use.
Yeah, it sounds more daunting than it is, but like, as long as you follow the instructions, it's like, oh, it built.
So to set the collector's base image, you can specify the image attribute in spec.image as we've highlighted here. So if that all looks good and everything's just checking out, but you're not seeing data in the backend vendor that you're using to ingest your data, you might need to configure a license key or some kind of access token to make sure your data is getting to the right account. So check that you're using the right access token or license key for that account that you're trying to send your data to. And since you want to keep this information confidential, you can create a Kubernetes secret and store it, or use a secrets provider such as HashiCorp Vault, or use your cloud provider's secrets provider. So one example is to create a secret for your access token. So you can create a Kubernetes secret. If you go this route, don't forget to base64 encode your secret. And then once you have that, you'll need to add the secret to your OpenTelemetry collector CR definition. And you can do this by adding an environment variable to point to the secret, and then reference that environment variable name in your exporter configuration. Finally, confirm that you have configured the correct endpoint for your observability backends in your exporter configuration. And I know we've gone over a lot of configuration stuff, but it seems the vast majority of issues do just come from improper configuration. I'm sure a lot of you have experienced this at some point. Another place to look is in the operator logs for any error messages, and you can do this by running the following command. And now I'm going to let Adriana get into something really interesting.
Yes, thank you. Okay, we are going to be talking about zero-code instrumentation done by the OTel operator. So fun fact, the OTel operator does so many wonderful things. That's why I personally love it. And one of the things that it does is zero-code instrumentation. Now, OpenTelemetry allows you to instrument your code in two different ways, and you can do a mix and match. So there is manual instrumentation, and then there's zero code, also known as automatic or auto instrumentation. But before we get into what that is, let's talk about what instrumentation is. So instrumentation is the process of adding code to your software so that it generates those telemetry signals, i.e. those traces, logs, and metrics. So given that, when we're talking about manual instrumentation, it means you're going into your application code and adding those traces, logs, and metrics directly to your code. And you can think of that similar to basically adding print statements to your code, same sort of idea. So then you would imagine that zero-code instrumentation means the automagical insertion of instrumentation into your code, hands-free, you don't have to do anything. Now this is done courtesy of shims and bytecode instrumentation agents that intercept your code at runtime or compile time that then will put in that instrumentation into your code and into the third-party libraries and frameworks that you know and love. And zero-code instrumentation is supported for the following languages in OpenTelemetry. So we have Java, Python, .NET, PHP, JavaScript, and Go. And if you want more information, you can scan the, you can scan the QR code on the screen right here. Okay, so then what about zero-code instrumentation with the operator? So the operator does this courtesy of another lovely custom resource called the instrumentation resource, which is used to inject that instrumentation into your containers in Kubernetes. So let's look at what that actually looks like. So this is your instrumentation resource, and we are going to look at it in greater detail. So first off, at the top here, you can see that the API version, opentelemetry.io/v1alpha1, there's only one version of this one compared to the collector, and the kind is instrumentation. Now in the spec section, we are defining some environment variables over here. These environment variables are OpenTelemetry environment variables, and if you want a full list of the environment variables, I have dug that up for you. You can scan this QR code here. Digging in a little bit further, by the way, and if you want to see the API reference to see what each of these fields does, you can scan this QR code on the screen. Super handy. I go back to it many, many times. So if we look at it further, we have another section here called exporter, and we define an endpoint. Usually this is pointing to an OpenTelemetry collector, and which we now know what it is after Reese's lovely explanation. In addition, you can define propagators. So propagators are basically the glue that links your traces together to ensure that you don't have disjointed traces. So the traces tell the story of what happens in your application. So you should specify at least one propagator. You can specify multiple, and these are the valid propagators that are available to you. In addition, if you want to do any sampling, you can do some sampling configuration here. And then finally, we have another env section. And you might be wondering, okay, so two env sections, what's the deal? You might notice over here, it says Python env. So Fun fact, you can configure environment variables that are language specific. So when it comes to this instrumentation custom resource, you can actually define as many instrumentation resources as you want for a particular project. And you can, if your application is made up of multiple microservices written in multiple languages, you can actually configure it for all the multiple languages in a single instrumentation resource. So if you wanted to also define some configuration specific to Java, you would add another section here called Java, and then it would have the environment variables specific to just the Java auto instrumentation here. Or if you want to get super fancy, you can define an instrumentation resource per language that you want to auto instrument. So that's part one. So this defines your auto instrumentation configuration. But how, pray tell, do we specify what's being auto instrumented? And that's where we have part two. We have to add some special annotations to our Kubernetes deployment. So there are two ways to do the auto instrumentation association, if you will. You can add this annotation either to a namespace definition, like your namespace YAML, or you can add it to your deployment. We're going to cover off specifically adding it to the deployment. So in adding it to the deployment YAML, take note of the fact that we are adding it to as an annotation under the template metadata section, because remember there's the other metadata section up top here. Don't add it there, it will not work. Been there, done that, bought the t-shirt, will not work. So yes, we have to add this lovely annotation here, instrumentation.opentelemetry.io, and it says inject Python. Cool. But what if I wanted to do it for something other than Python, like Java? Well, guess what? You would replace that with inject Java. And as you see, the value of the annotation is true. And you might be wondering, are there other values? Well, glad you asked, because there are. So obviously, if you set it to true, it means that the OTel operator is looking for an instrumentation resource in the same namespace as your deployment. Now, you might be wondering, what if there's more than one instrumentation resource in the same namespace as your deployment? And the answer is, it's going to get confused and things will fail. And I'll explain how to get around that in a sec. The other value, possible value, is false, so you can turn that off and on, yay. Now for our case where we have multiple instrumentation resources in the same namespace, instead of using true, you specify the instrumentation's name. So remember, instrumentation resource has a name field, so you put the name of that instrumentation resource in the annotation value instead of true, and it'll find the appropriate one. But how about if my instrumentation resource resides in a different namespace than my deployment? We've got that covered as well. All you have to do is specify the namespace name / the instrumentation name, and you are golden. Of course, you need to make sure that the operator has access to both namespaces, otherwise things will not go well for you. Another interesting, fun thing that you can do when it comes to auto instrumentation is suppose your deployment is made up of multiple containers. Well, what if you don't want to auto instrument all of them? In this case, we have another lovely annotation here where you specify the container names, where it's saying here, yes, I'm auto instrumenting this with Java, but I'm only wanting to auto instrument my app and my app 2. Awesome. But what if your pod is made up of containers that are a mix and match? You've got some Java, you've got some Python, no problem. For the Python containers, we are going to add another set of annotations here saying we're going to inject Python, and it's going to apply to my app 3. And so now we are auto instrumenting my app 3 using Python, my app and my app 2 using Java, and Bob's your uncle. Yay. Okay, that's all well and good. You're like, cool, this theory totally makes sense. I got this. And then you try it out and things don't work, and you're like, crap, now what? A little bit of despair, especially if you're testing the stuff in the middle of the night. That's usually what happens to me. So first thing that I would do is check to make sure that the resource was deployed. And I know this sounds stupid, but like once I was testing stuff out in my repo, and I was like, what the hell, why is this thing not being instrumented? And guess what, I forgot to deploy the instrumentation resource. Whoops. So you can check that by running this command, kubectl describe OTel inst. This will basically list all of the instrumentation resources in your given namespace. Number 2, check the order of deployment of your auto instrumentation. So this is really important. So remember to auto instrument something using the operator, you have to deploy that instrumentation resource, and you have to deploy the deployment resource with that annotation, but you have to deploy the instrumentation resource first and then deploy the deployment. Why? Because the OTel operator, when it reads that annotation, it's going to be like, oh, cool, I'm looking for an instrumentation resource. You don't find it, it doesn't know what to do. Because what it does behind the scenes in your deployment resource is it creates an init container for injecting the auto instrumentation into the containers that you want to auto instrument. So if it's not there, it can't do its job. So how can we tell if we actually did that? Well, you run this command here, kubectl get pods. This represents the pod for your deployment in your namespace, and it's going to look for any init containers. If this returns no results, you know that that auto instrumentation did not happen. The other thing to check is those auto instrumentation annotations, because remember, we can specify annotations in 2 spots in our deployment, up top here, not the right place, and at the bottom here under template metadata, that is the correct place. In addition, are you auto-instrumenting the right language? So suppose you have Python containers in your deployment, but you select inject Java, well, that's not going to work. Also, make sure that you are using the correct value of your annotation. So if you have multiple instrumentation resources in your same namespace as your deployment resource and you set this to true, remember it's not going to work because the OTel operator is going to be like, oops, I don't know which one to select. Another thing to check out is our endpoint configurations. Now remember, in our instrumentation resource, we have this endpoint definition here, which, as I said, typically points to an OTel collector. So you want to, usually, I prefer to use the fully qualified name of the collector, so that's the name of the collector, and then the namespace.svc.cluster.local. My collector happens to be deployed in a namespace called OpenTelemetry. If your namespace is Bob, you replace OpenTelemetry with Bob. Another thing to check out here is port 4318. So the collector can accept both HTTP through port 4318 and gRPC through port 4317. Normally it doesn't matter which one, choose your favorite one. However, for Python, it only accepts 4318. So if you're using 4317 and trying to auto-instrument Python code, it is not going to work. And for more information, scan this lovely QR code over here. Now, in addition, you might recall that Reese mentioned that we can also deploy the collector as a sidecar. And if we're doing that, the exporter definition is different for sidecar collectors. It has to be HTTP localhost and then either 4318 or 4317. Again, if it's Python, it's got to be 4318. And then, if all else fails, pray to the operator gods, check those logs. We check the logs with that same command that Reese showed earlier. So check for the word error. That's always a good indicator. But we also recognize that maybe not everyone has access to those operator logs, right? So if you're troubleshooting, an SRE platform engineer installed the operator for you, you probably don't have access to this. So maybe the next best thing is to do kubectl get events on your namespace and take a look and see if there's anything funky going on. So that is it. Now I'm going to summarize all the stuff that we've discussed. So if you've been falling asleep, now's the time to wake up, take some screenshots, because I'm going to review all the cool stuff that we covered. So OTel operator, make sure that you have that cert manager installed first and foremost, because if it's not installed, it no worky. It is a dependency. Number 2, make sure that your resources have been deployed. Yes, sometimes we fall asleep behind the wheel and we forget that we've deployed resources. We've deployed them in our heads. Unfortunately, that doesn't translate. Check the API version for the OpenTelemetry collector, because there's v1 alpha 1, v1 beta 1. They're similar but different. They have certain nuances, so make sure you're using the correct constructs with the correct API version. Check that deployment order for auto instrumentation. Remember, the instrumentation resource has to get deployed first, and then we deploy our deployment. You want to also make sure that your annotations are added to the right place. Remember, it's not in the root metadata section, it's in spec template metadata. Check those endpoint configurations. Remember, they're slightly different if you're doing sidecar versus non-sidecar deployment of your OTel collector. And remember, 4318 for Python auto instrumentation. And then when all else fails, check those lovely OTel operator logs for error messages. And now we will leave you with some lovely, beautiful resources to check out. So Reese and I have a blog post version of this talk. So if reading is more your jam, check it out. We also have an example repo for this talk where we have played around with this stuff, and so feel free to scan that. I have it set up so that you can run it in GitHub code spaces or dev containers, so you don't have to deal with all that setup crap that's super annoying for these things. I also have a blog post on the OTel blog on troubleshooting the OTel operator. There is an OTel operator compatibility matrix so that you can see what versions of the collector and cert manager and all this stuff are compatible with each other, because nothing's worse than, you know, versions that don't play with each other. I also wrote a lot of blog posts on the OTel operator on my Medium blog, so definitely check that out. I'm a little bit obsessed with the operator. I think it's really cool, so I did a lot of exploration last year. And finally, if you have questions on the OTel operator, join CNCF Slack. There is an OTel operator channel. Folks are super friendly. They've answered many, many of my questions. Everyone's always willing to help. That's really what I appreciate about the OTel community. And I'm going to do some shameless plugs for myself. So I have a podcast called Geeking Out. My daughter designed the logo, and there's a capybara, because as I mentioned, I love them. I've had some really cool guests on my podcast, including Kelsey Hightower. Autumn, who's sitting at the front, she's like my latest guest. Reese, I think, was like guest number 2. And I've had like Charity Majors, Liz Fong-Jones, Abby Bangser, all sorts of cool people on there. And also, if you are looking to learn about OpenTelemetry, I have a video course on O'Reilly on observability with OpenTelemetry. So if you have an O'Reilly subscription and video is your jam, check it out. And we should thank also Reese's cat, Taco, for being like the best slide model ever.
Thank you. Thank you. It's hard work being so cute.
Yes, and Reese did a great job with the cool animations and cat pictures throughout the slides. I was honestly like laughing my ass off when we were going through the slides. So, thank you. So thank you. Hope you learned something cool today.
Thank you, guys.
So I've deployed OTel operator, and one issue I've been running into is when we do a GitOps bootstrap of the cluster, everything comes online, it retries, it fails, eventually everything works. But the one thing that never works is auto instrumentation until I roll the pods manually. Is there a way to tell the operator to just kill the pods on my behalf and then like restart them? Because it seems like I have to do it manually every time.
Really?
Yeah, it doesn't like get rolled automatically.
Oh, that's so weird. I've never encountered that before.
Yeah, my edge case might also be unique. We're tearing down the cluster and then bringing it back up for development.
Yeah.
And it's only at that time where the annotation's there, but the operator wasn't fully running prior to that.
Yeah. I mean, yeah, the only weirdness I've experienced personally sometimes is like bringing up the collector and then that doesn't start up properly and then it causes all the other things to like go caca.
Yeah.
But I've not experienced that, and as far as I know, I don't know of any construct to tell.
Yeah, we were thinking about rolling our own tool that would just check kill
Yeah,
it after
yeah.
5 minutes or something if the sidecar wasn't running. And then last question I had was, given all the configurations involved, how do you recommend doing shift left? Like for developers to be able to self-service this? Like where would you recommend drawing the boundaries from a platform team versus what the developers own?
Oh, in terms of like instrumenting their code? In terms of, oh, well, I mean, I personally, like, I'm a bit of a control freak, so as a developer, I would personally want to be able to do those configurations myself, like the auto instrumentation configuration, because in my opinion, I don't know that the platform team would necessarily have that additional context for that sort of thing, so that's where I stand personally. Yep.
Hi. I was wondering if you end up relying on auto instrumentation a lot versus like sort of explicit instrumentation, and where maybe you draw that line. Because I think it's interesting too, like where I work on the sort of platform side of things, and so we trust our engineers to do the right thing, but sometimes I also understand that it's a lot of maybe tweaking, a lot of like needing to understand the details, like the fact that, oh, if you run on with what sidecar mode, suddenly everything's localhost. I feel that there's a bit of leaky abstraction maybe.
Yeah.
So I was wondering sort of where, just your personal experience where that line is drawn, or if you even feel the need to draw the line at all and you think auto instrumentation just mostly works.
I mean, so auto instrumentation I think is a double-edged sword, right? Because I think it's one of those things where it really like removes the barrier to entry for instrumenting your code, and people are like, oh great, I don't have to do anything. But that's awesome, but it only gets you so far, right? I think if you want like more granular information to really be able to troubleshoot, I think you're going to have to delve into manual instrumentation, and that unfortunately, or fortunately, I mean honestly, I think it's the job of the developer. In the same way that like we're used to like doing log messages and print statements and whatever as developers, you know, let's get into the habit of instrumenting our code. The other thing around auto instrumentation is you got to take care of the fact that like sometimes you just get bombarded with data, and a lot of the time it's crap that you don't need. So you have to make sure then that you switch off. And I know, I can't remember for the operator, but I know like in non-operator scenarios, there's a way to basically say, hey, these libraries that are auto instrumented that I use in my code, I do not want them turned on because this is just too much stuff. I don't know if you have any additional thoughts.
I was just going to add that with OpenTelemetry being, you know, an open standard for instrumentation, you know, it kind of removes the need for, if you're moving to a different backend, you don't need to pull out the old instrumentation and put in new ones. So that is something to consider if you're thinking about instrumenting with OpenTelemetry. Oh, in the front.
How do you decide between the cuddle or the helm? Like, what are the trade-offs, and how do you make that decision? Is it just kind of like whatever you're using, or?
I feel like Helm you probably would do in like a more organized setting, like, you know, you're part of like an official like CI/CD process. And I feel like if you're just like messing around with it locally, like probably kubectl. But to be honest, like they both work equally fine. Yeah.
Thank you.
Thanks for the talk. I was wondering, there's a lot of vendors and companies have now made their own forks of the OTel collector.
Yeah.
Like Grafana's got one, AWS has one, Splunk has one, et cetera, et cetera. What is your take on when to pick the vendor one? Like, obviously people are probably streaming their APM to Datadog or whomever. What influences your decision on which collector to take?
So I think, you know, I'm an OTel purist, and you know, my stance is I always like to ensure that no matter what, like you are using an OTel collector, but when it comes to like these vendor forks, like they're still like the OTel collector, but they've included components that play nice with their tooling. So in some cases, for example, some of the vendors will say, hey, like we can provide support if you use our OTel collector, so then that becomes kind of a compelling story, especially like if you work for a large enterprise. And you know, large enterprises and open source can be a little bit like scary, right? Because large enterprises like, I will use open source, but like tell me someone I can throw money at in case something goes awry. And I think that's one of the advantages of using the vendor forks, is that you know that the component, like these are specially curated components that will play nice with that vendor backend, and you will get that extra level of support. It's not to say that they've added some like, you know, magical extra crap to it. It's just that they know that those components are guaranteed to work with their collector, which is different than like saying, you know, oh, let's go with a vendor-specific agent, and then that's no longer, that's a different story. But I think if you do the forks, you're still staying within, you know, like the OTel family. You just have that like little extra guarantee. And there's also nothing that stops you from like using a vendor fork and then building your own like collector distro, which includes like the vendor components plus like your own extra stuff as well. So that's kind of the magic of the collector.
More questions?
Earlier, multiple times you've shared you could have a centralized collector versus a sidecar. I was just curious on if you could share some of the pros and cons with each approach.
Ooh.
I think it depends on your scenario. Like I think the stateful set is probably the most popular approach to doing deployment, collector deployment, especially because you know that anytime you like nuke your collector, it's always going to be like OTel collector -1 or whatever, and you can always reference that without like, you know, worrying about like, is it going to be a different pod name or whatever. Sidecar is still used. I guess it depends on like how close you want your collector to your data. Really is, I think, what it boils down to at the end of the day. You know, some people will do like a sidecar per deployment. Other people will be like, you know, I'm okay with like one collector maybe in my Kubernetes cluster. And it's one of those things too, and this dives a little bit into like some sustainability topics too, where you end up with certain collector configurations that, you know, is it more efficient from a power usage standpoint to have a bunch of collectors that are specialized versus one big collector that does all the things, right? So I think that's where like it might be worthwhile to like do some internal benchmarking and see, you know, if it's worth it on the power usage, on the cost, that sort of thing.
And I think from what I've seen too, a lot of organizations will use a combination just depending on what their goal is. Yeah, there's like different things to consider with where your collectors are located and data, you know, potentially losing data between like if they have to travel further and such.
Any more questions? Okay, awesome. Thank you very much for that talk and for the operator.
Thank you.
Thank you. Thanks for having us.
Our next session in this room will start at 3:45. I'll look up in a minute what that is, but there will be more advanced Kubernetes cloud native hackery in about 30 minutes, I think. Yeah, about 30 minutes.
just checking. I'm just checking batteries. Yeah.
How about this one?
Looks great.
Yeah? Okay. Oh, I can hear myself. Yeah. Yeah. Perfect. That's good. Just in case, I'm going to.
Welcome, everybody, to another great advanced Kubernetes Cloud Native session. This one is all about using web tokens for authentication, presented by the redoubtable Paul Yu, who's a developer advocate at Microsoft. Also presented a great tutorial yesterday, which unfortunately you've already missed, but you can catch it on video.
Yes.
And with that, Paul, take it away.
Thank you, Josh. Yeah. Thank you. Appreciate it. So my name is Paul Yu, and as Josh mentioned, I am a cloud native developer advocate here at Microsoft. And what does that mean? Well, that kind of means I just do a lot of things in the Azure cloud, Azure Kubernetes service, and just Kubernetes in general. And yes, I did run a workshop yesterday on how to be a Kubestronaut, and I do have that content still available on my GitHub. And so if you just navigate to my GitHub, which I'll share at the end of the session, you can see all that content and kind of do all that stuff on your own, okay? So yeah, I'm super excited to be here. This is my third SCaLE conference and my second SCaLE where I'm actually speaking, so it's really good to be here, especially being that I am local to the area. So I am born and raised here in the South Bay, so about 45 minutes away. If you're familiar, Long Beach, Carson, Torrance area, that's kind of like where I'm from. And yeah, so really great to be here. But this talk, though, is something that I'm excited about. This talk is really about Kubernetes and structured authentication. And when I first heard about structured authentication and its ability to support multiple job providers, the first thing that popped into my head was really not technology related. Being a SoCal native and listening to local artists, right, growing up, the first thing that just popped into my mind was the song titled "Drop It Like It's Hot" by none other than Mr. Snoop Dogg himself, and Pharrell. Got to give a shout out to Pharrell. But that's kind of like the inspiration behind the title of this talk. And hopefully by the end of this talk, you'll see how easy it is to jot it like it's hot and add multiple job providers to provide access to your Kubernetes API server, whether that's to users or for your workloads running in the cluster, right? But yeah, this session, I'll show you what this new Kubernetes feature is. It's still currently in beta. And I'll show you how to use it. But I also wanted to tell you just a little bit behind like its origin story and how the feature came to be. So if you don't mind, this is actually the only slide I have. I just wanted this slide because I wanted to say I incorporated Snoop Dogg into one of my talks, and so that was a goal of mine. So there we go. I'm actually going to test the demo gods today. I know yesterday there was a little bit of issues with the Wi-Fi. It was just a little slow. So I'm really going to test them, and I'm just going to flip over to my browser and terminal and attempt to do this live on the conference Wi-Fi and explain as I go, so hopefully you guys can follow along. If the Wi-Fi is not working, I do have a backup recording, so I could just flip over to a recording. But other than that, we'll just try it live. How does that sound? All right. So, first thing I want to start off with is when it comes to structured authentication, what that means is your users or your workloads, they are going to authenticate to a specific OIDC provider, right? And so in this demo that I've set up, what I did was I used Terraform to basically provision a application registration in Microsoft Entra ID. I still can't get over the fact that they changed the name to Entra ID. I keep calling it Azure ID, but Azure AD, but yeah, Microsoft Entra ID. So I do have a client application over in Microsoft Entra ID, and yeah, the internet is pretty zippy, so, well, I think I spoke too soon. We'll see here. There we go. It's not as zippy, but that's okay. So I do have this one application here, and I just called it K8's OIDC. And if I click into this K8's OIDC, I can just show you like what you need to configure, especially if you're like an Azure user. I also have a separate demo using Okta, which I'll show you in a second. But basically what you're gonna need when you set up an application registration is you're gonna need this client ID, and then especially for Azure, you're gonna need this directory or the tenant ID. From there, let me show you how to actually configure the authentication bit. The most important thing here is that when you authenticate to the Kubernetes API server, especially using kubectl, there's a plugin for kubectl called OIDC login, and that OIDC login actually runs on a localhost port 8000, and so you're going to need the redirect. You're going to need to be able to redirect back to that particular endpoint, and so that's pretty much the configuration there. When we're talking about JOT providers or JSON web tokens, we're really talking about these payloads that have information, the user information, and that has claims in them, right? And so what we have here, or what I've configured, is I've added this group claim, and I've made sure that that group claim is included here with the name of group, so that that claim is available or accessible from the ID token, okay? So that's pretty much it from the setup perspective. The other thing that I wanted to show you here is basically there is groups, right? Because I wanted to emit the group in my JOT token, and so I have one group here in my tenant, and I've called that K8 admin, okay? So if I click into that group, one thing that you're going to need to make a note of is the object ID. And so this is going to be like my identifier in the JOT token, okay? So if I click over to members, I've only added myself as a member of this K8 group, okay? So that's pretty much it from the setup perspective on the Azure side, at least. What does that mean? Like, what do I do with all this information? Well, if I jump over to the Kubernetes website, and over here under API access control for authenticating, you should be able to see, and if I just drop this down just a little bit to see the, yeah, I wanted to see the table of contents here. You can see that there's a bunch of different ways that you can actually authenticate to the Kubernetes API server. But the important thing I wanted to call out is that we're really focusing on OpenID Connect tokens, right? So if I just click on that, it'll take me down to the section where it does a little bit more explaining. I'm sorry, I tried to zoom in and it bounced around. Let's see, hang on a second, let me try to find my spot. Let's click that again. Okay, so it talks about the OpenID Connect tokens, and it kind of like goes through the song and dance, right? Like that's what I call the OIDC handshake, right? Like you're exchanging tokens back and forth, and that's kind of like the deal and what's going on there. In terms of like configuration, if I scroll down here, configuring the API server prior to Kubernetes 1.30, the only way to configure an OIDC provider is to use these flags, right? And if I just do a search for OIDC dash, you can see that there's a ton of flags over here, right? And so there's about, I would say about 9 flags or so. And the things that we need to be aware of here is like the issuer ID and the client ID, right? Because those are the things that we configured in the application registration. Also the username claim, that's going to be important because I want to know who that user is. And then if I scroll down here, this is the group claim, right? So we can add this provider, this OIDC provider, to the Kube API server, and the Kube API server, or excuse me, when you authenticate, it'll know like, oh, okay, I need to go out to this issuer, which is in Microsoft Entra ID, and I can do the authentication, accept that JSON web token, and then exchange it and convert it into an actual user in Kubernetes, right? So let's see how we can actually use this, or let's see what a JSON web token actually looks like for the folks that haven't really seen that. So what I'll do is, like I said, I've already pre-provisioned all this using Terraform, and so I'll just go ahead and export some variables here. We got the Microsoft tenant ID, and then we'll grab the Microsoft client ID, and then of course we'll grab the issuer ID as well, okay? So I have those in my variable, and the first thing that I want to do is basically, I want to mimic a device code flow authentication, right? Because that's really what's happening when you're authenticating using kubectl. And so what I'll do is I'll make a call to the device code endpoint, and I'll ask Microsoft Entra ID to give me a device code for this particular client ID, and using all these scopes, right? Because I want the user's information, and basically I want to authenticate myself against that Azure AD application. And I just realized I said Azure AD again. Sorry. Microsoft Entra ID. So once I receive this payload, it's coming eventually. This is the Wi-Fi. It's, okay, there we go. We eventually got that payload, and the one thing that I need to do now is extract the device code and the user code. I don't know if you've ever logged into like Azure CLI from the terminal before, but this is essentially the same flow. So I'll go ahead and print out the login URL and the device code, and I'm a little nervous about the login part, but let's just go ahead and click it anyways. So I'll go ahead and do the device login, and once it pulls up, it's going to ask me for what that user code is. And then I'll get my phone nearby because I do have to MFA in. Eventually, do you guys see the, yeah, it's just spinning. We'll just wait a little bit. There we go. Okay, so I'm gonna go ahead and paste in the user code, click next, and I should be prompted for MFA eventually. There we go. So I'm already signed in, and it just wants to make sure that I want to use that particular account to log into the K8's OIDC application. So here we go. I should be prompted on my authenticator app and put in the secret code, and okay. Because we want to be extra secure here. It'll eventually go. Get on, huh? Go, go, go. Yeah. It'll come. I know. I'm certain of it. I have faith in it. Faith in the Wi-Fi. Let's see. While we're waiting, has anybody used the OIDC provider in their Kubernetes cluster yet? Okay, we have like 2 hands back there. Cool, cool, cool. So this is fairly new to a lot of folks. That's why I'm hoping that we can actually get this to work. Okay, I think I'm gonna give it like 10 more seconds before I bounce out to a recording. I really wanted to do this live. Yes, yeah. So I basically ran the REST API endpoint to the device code login to get my device code. So I'm basically logging in as myself into the K8's OIDC application that I created, and I requested a device code flow login, And so what that'll give me is the really long device code and then a user code. And basically, I enter that, and my device code becomes active. Once that device code is active, I can then, which is the next part here that I'm waiting on, what I could do then is basically exchange the device code for a bearer token. And then inside of that bearer token is a couple of different JOT tokens that I wanted to show, which I don't think this is going to come back. So pardon me, let me just flip over to a demo recording. So let's see if this works a little bit better. And if it does come back, I'll periodically check on it. Let's do this. Let's put this in full screen mode and put this over here. And nope, that doesn't want to come back. So let me just fast forward this just a little bit. So this is the login part, right? So this is the part that we left off on. So basically, we're gonna log in, and then I select my account, and then I would MFA, of course. I should fast forward this just a little bit. Okay. So at this point, I'm actually logged in to the K8's OIDC application, okay? And so from there, what I can do is I can literally exchange, it's like a long device code that it gave me. I should have printed it out just for visualization, but I can exchange that for a bearer token. So here, what I'm going to do is basically, if I can mark this up, I'm gonna call now the token endpoint and give it the Microsoft Client ID again, because this is what I'm authenticating against. And then here is the device code. Because I've went to the browser and I did my login bit, I can now exchange this for the actual device code, okay? So once this comes back, this is a really long piece of JSON. But basically, over here is what we're getting the bearer token, and then we're also getting a few different JOT tokens in here. So we have the access token, and then down at the bottom, I think I scrolled down in the recording. No, I don't. So what I do is I basically, I'll take that access token, head over to the jwt.ms website, or it could be jwt.io, and I can look at the decoded token. And the thing that you need to look out for here are claims like the email address, right? So this over here, email and name. So that kind of information comes through in the access token. The other thing that I wanted to show you is the ID token. So if I just grab the ID token contents, copy it to my clipboard, and then flip back over to jot.ms, I can paste that in, inspect the claims, and the one thing that I wanted to kind of show you here is over here in the ID token, we also have the groups claim, which we're going to use, okay? So what I can do from this point is take this information and I can actually configure my Kubernetes cluster, right? And so I'm using a local kind cluster to demonstrate this. And inside of the kind cluster, you can actually see that kind is bootstrapping using kubeadm as well. So all the documentation that you saw online is still valid. And what you saw here is the extra arguments that you would pass. So these are flags that you would pass into the kube API server. And so I can pass that in, and this is pretty unique to kind. This is the kind cluster manifest. And so I can actually use that, create a custom cluster control plane component, and then I can use that manifest and create the kind cluster, okay? So this is actually using Kubernetes 132, And then as soon as the control plane comes up, I can do a couple of tests. Okay, so with the kind cluster in place, what you need to do is you need to add a user entry into your kube config file. And here, I'm adding the Azure user. And the one thing that I wanted to especially call out is this is basically a plugin for kubectl. You could use accrue to install that. And what you want to do is basically say, anytime you're using kubectl to log in, it's going to use this plugin, and it's going to call the getToken method. And in that method, it needs to know what the issuer is and what application that you're logging into. And remember, the application you're logging into is basically the client ID. And then you're asking for additional scopes against that, okay? So once you do that, you now have a kubeconfig file with a particular user on there. And so you can use that to actually deploy a pod as that specific user. Now you can see here, once you did that, the OIDC login kicked in, sent me over to a web page, and it knew I was authenticated and redirected me right back. Now the problem here is the pod was not deployed, right? It says this is forbidden, because this user cannot create the resource pods. And why is that? Well, that's because I didn't configure any RBAC, right? So I can authenticate, right? Authentication, but I wasn't authorized to do this stuff. So what I do here is basically, I create a cluster role binding, which basically binds my identity to the cluster admin role, and I should rewind it back just a little bit because I want to show you here. Basically, the cluster admin role is here, and the group identity is here. Remember, this is the group that I showed you in the Azure portal. So because when I authenticated my group membership, this showed up, so now I am basically a cluster admin. So what I can do from that point is basically do the same command, right? So apply the role binding and then try to deploy the pod again. So this time, because now my identity is linked to that role binding, then the pod is successful, okay? So that's basically the whole, I guess, concept around using a JOT provider or an OIDC provider to have users authenticate to kubectl, which is great. But that's just like set the context, like what this structured authentication can do. And so what I'm gonna do here is basically I'm gonna blow away that cluster and redeploy it, okay? But this time I'm gonna redeploy it using structured authentication, okay? And if I head over to some docs here, just to give you a little bit of a backstory, and what I'll show you here is how this feature came about is, you know, like any other good open source story, it all starts with an issue. And this issue here, if you look at the date, it was created like almost 3 years ago. This issue has been edited, I guess a few times, I don't know why, but you can see that the, oh boy, okay, here we go. You can see that the original issue over here says, enable OIDC federation on AKS to enable multi-cloud or alternative identity solutions. I mean, that was the gist of it, and that's what folks wanted, right? And that's what folks were clamoring for. And if you look at this issue, it gets pretty entertaining. It's a really long 3-year issue, right? A lot of back and forth. Other cloud providers have implemented a similar solution, and I think they kind of like implemented like in their own unique way. Since then, the Azure Container Upstream team, which basically a lot of them work within the SIG-Auth, so the Auth Special Interest Group. So some of these folks here that you see in the names over here, so folks like Rita Zhang, Jordan Liggett, Mo Khan, Anish, these folks all got together and said, hey, you know what? rather than having individual cloud providers or whoever implement their own multiple JOT provider solution, why don't we work together and actually try to build something for Kubernetes itself, right? And thus, this issue was created to basically propose a new solution to kind of solve this problem. And this KEP was born, right? And so that KEP is all documented over here, gives you all the backstory behind like the motivation, the goals, the design, all that good stuff, right? And eventually what happened was, I want to say like last year or so. I want to say last year, yes. Last year, yeah, less than a year. Anish came out with this blog post on the Kubernetes blog and announcing basically that as of Kubernetes 130, structured authentication is in beta. And he wrote this really good article about also the backstory, what it is, right? How to use it and things like that. And so that's kind of like where we are. Now, are we at the point where it's in AKS yet? No, we're still waiting. But it is in upstream Kubernetes and it is in beta for you folks to test out. So let's scroll down in the authentication docs over here and try to see how we go about implementing this. So basically, if you see over here, it says, remember we had multiple OIDC flags? There was like up to 9 that you could configure. Well, with structured authentication, now you're just dealing with one configuration file and one flag that you put onto the Kube API server, okay? And so that sounds really good, right? So let's see what this looks like. So we're gonna take a look at this structured authentication file and kind of like migrate our original OIDC implementation and kind of like fit it into this structured authentication manifest. And you can see here that we're kind of in the same boat. Okay, my pointer's not working, but the issuer ID is here. The audiences is now the application or the client ID. And if you can see here up in the structure of the YAML manifest, basically it's a JOT spec and it allows or enables multiple JOT providers, right? Because this is now an array. So you can bring in up to 64 JOT providers in this solution. And for each issuer, it's gonna be unique, especially on the Azure side. It's gonna be per tenant. But if you configure multiple application registrations within your tenant, then you can add multiple audiences as well. And then we can have like claim mappings over here. So where we were specifying the username and mapping it to email, we're doing the same thing over here. So let's go ahead and push that forward. So we'll take a look at that, and then we can actually take a look at the new kind config, or excuse me, the new Kube API server configuration, right? And so you can see, and I really wish my pointer was working. Stop. There we go. Okay. So here, the authentication config, we only have one flag now that we need to pass into the Kube API server, okay? And because I am deploying this inside of a kind cluster, I do need to mount my local file into the actual Docker container because remember, kind is basically Kubernetes in Docker, so it's just all containers. So I'm mounting my local file into the Docker container that's gonna run the Kubernetes cluster. And then inside there, this is just normal volume mount stuff in the Kubernetes pod itself. So we will actually take this manifest, this cluster configuration manifest, tie that with the structured authentication manifest, and then now, boom, we have a cluster that has structured authentication enabled, which is pretty cool. So we'll wait for this to start up. Okay, so now we have a cluster, and we can just do the same thing, create the cluster admin role binding, I won't dig into this too deeply because we've already done that. Add the user, Azure user entry into the kubeconfig, and then we could eventually use that Azure user to create a pod. So this is the authentication bit that happens again, and then there. Now the cluster's using structured authentication. Now, that's great. Remember what I said? Jot it like it's hot. You can add in multiple job providers. Well, that's what we're going to do here. And so in the Terraform script that I had set up, I've also set up an application over on the Okta side, and I am signed out. Let's see if this works. Boom, 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 boom. If it doesn't work, then we'll just move on and I'll kind of show you. But basically, it's very similar to the Azure's application registration, but you go to the Okta portal, you create a new application. You're going to get a client ID. You're going to get some configuration on how you want that authentication to happen. And then same deal. Here we go. Okay. But will page refreshes work? So I'll go to applications, and I have an application called K8's OIDC. Same name. I got real creative, right? So we have the client ID here, client authentication, and then down here, I also configured that redirect, the redirect URI, right, for the kubectl to work. And then from there, what I did was go into directory, create a new group. But this time, they're not cluster admins. I created K8's readers, okay? And then within that K8's readers, I basically assigned myself to the K8's readers group. So from there, I can basically pull out the information from the Terraform outputs and basically use that to configure a brand new job provider, okay? So I'm going to drop in a brand new job provider, and it's as simple as basically just appending that to the structured authentication file, okay? And very similar to the Azure bit, it just required the issuer, client ID, and then the claim mapping. Now, because this is actually running on a Docker container because we're working in kind, you can actually basically inspect the Docker container, and you can see inside the Docker container, it actually shows up. So I have now a second entry for a job provider, and then I could go over here to the Kube API server logs, and I could kind of see what the Kube API server was doing. And the cool thing here, and you can kind of see this, the cool thing here is now I don't need to restart the Kube API server. It just picked up the change in the file and just reloaded that, hot reloaded that, essentially. And now we are ready to go. So that's really handy. From there, what I can do is I can do similar things like create the role and create the role binding and basically test this out. So here, I want to kind of like limit the scope of this role. So we have a pod and service reader, which could only read from pods and services, and then can only perform these specific verbs, get, watch, and list, okay? And so what we'll do here is basically bind that to a group, which I'll show you right here in a second. So if I look at the role binding, you can see here that we are taking that role that we just created, and we are binding that to the K8's readers group. Okay? Because now when I log in and authenticate against my Okta account, now the group that I get back, or the group that is included in the JOT token, is K8's readers. Okay? So what we'll do from there is basically test this out. We've got to add the Okta user entry. Same deal as before. We're basically adding in the Okta user, passing in the Okta issuer URL and the Okta client application ID, and then we can actually test to see if we can get the pod. So the authentication happened against Okta. There's no web page that actually spun up, but it just happened from the web browser. And I can, oops, I think I skipped over a little bit, but basically the pod got created, but the node is, being able to look at nodes is forbidden because that wasn't within my role definition. So that works, okay? And we can do that basically just by editing the structure authentication configuration file. Now, what's next? What else can you do with structured authentication? So if you head back over into the documentation here, and if you scroll down, you'll see here that there's a sample manifest, and this is like heavily documented, so it's a lot to kind of like sift through and read through. But if you scroll down here, you can actually see some claims validation rules, right? And so you can actually add some rules. So for a very specific claim, you can ask for a very specific value, or you can start to build these more powerful things called expressions. And these expressions are using the SCaLE expression syntax. And so if you go look at common expression language and you go see, okay, what is this thing? Well, common expression language is basically a way for you to declare validation rules, policy rules, constraints, which all happen at the Kube API server, right? And so it's a very efficient method of basically evaluating requests that come in. And so you can actually take that and apply that to your structured authentication. So let's go take a look at what that looks like. So what I'm doing here is basically I'm just appending to my existing structure authentication config. So this is against the Okta JOT provider. And basically, I just wrote a simple validation rule that says anybody with the name of Bob is allowed. So if there's any Bobs in the house, you can access my cluster, okay? If not, then sorry. So I added that configuration, and now we can go back and check to see if that actually got loaded. And yes, we can see that there's a claim validation rule that says we're only allowing Bobs to come in. And so we can see here that the configuration file was reloaded. And because the validation happens during the time that the JOT token is received, I have to basically clear out my my OIDC login, so basically clearing out the token cache. And then from there, I can basically test again, which will cause a authentication thing to happen, and then boom. Because I am Paul and not Bob, I am not authorized to do anything in the cluster, okay? So that kind of sucks. So I do want to change that back. And so what I'll do is I'll basically just run through, and I think I goofed up the sed over here because sed and vim are hard. Let's just scrub through it. There we go. I think we should be on track here. Yeah, eventually. There we go, slow typing. So we just flipped it back and said, okay, now anybody with the name of Paul, because I think Paul's are more trustworthy than Bob's, I can basically update that. And it just updates on the fly. So as soon as I make that change to the structure authentication configuration file, we are basically good to go, right? So we can just look at the Kube API server control plane logs again. We can see that the configuration has been reloaded, clear out the cache, and then basically just test as my Okta user one more time, okay? And so we can see here that it was a very easy to use the structured authentication approach to secure your Kube API server, to grant others access to your Kube API server. and all just by manipulating a single file, and then the Kube API server just basically just reloads it, which is a whole lot better than waiting for the Kube API server to basically restart itself, which was a little bit of a pain. So that's basically it. That demo went a little bit faster because I anticipated some slowness on the internet. But yeah, basically what's going on is we are, or I should say, the AKS team is basically still working on this. This feature is still in beta, so it's been in beta since 1:30. And then if you scroll all the way to the bottom here, I would say the AKS team is actually moving forward and hoping to have this feature enabled for public preview in AKS clusters by June 2025. That date has slipped. I mean, we're like 3 years in, but good news is that it's a feature that's in upstream Kubernetes, and you all can try it out now, okay? Let's see, what else do I have here? I would say if you want to get involved, just as a recap here, multiple job providers supports up to 64. I don't know if that's going to be an issue for folks. I mean, 64 sounds like plenty, but when you talk about having your workloads inside your cluster authenticate to the Kube API server, you know, that might be, you might need to want to talk to folks to see if that could be increased. On the Azure side, I think we are going to limit that to well below 64, but if you have concerns or if you have needs, definitely reach out about that. The cool thing about this whole new structured authentication and the OIDC approach is that it basically supports any JOT compliant token provider, right? So I used Azure in my demo because it was convenient, and so was Okta, but I mean, anything that returns a JOT token, you can actually use for structured authentication. The other thing that I did mention is multiple audiences. So if you have one tenant and you have multiple applications, you can definitely configure multiple audiences, which is cool. And then that hot reload feature, I thought that was slick. Not waiting on the Kube API server. And then, of course, the cell expressions, pretty powerful stuff that you could do there. I just wrote a very, very simple claim validation, but you can actually use cell for claim mapping as well. So if for whatever reason your job provider provides data in different names, you can actually use the cell to basically map them into the fields that you need them to be in inside of the Kubernetes cluster, okay? And so in terms of like what's next, I guess the call to action for you all is to basically try the feature out and provide feedback. It is in beta. If you, for whatever reason, run into any issues, or if you have thoughts on how this thing could be improved, we definitely do invite you to join the SIG-Auth community calls. There is a Slack channel. It's SIG-Auth Authenticators Dev, which is a mouthful. And if you have any specific feedback items in regards to like Azure Kubernetes service and how that should be implemented, they're still, I think, in the development phase, so now is a good time to get in on that, okay? So yeah, so with that said, that's all I have in terms of structured authentication, and yeah, keep jotting, I guess. Feel free to reach out at any point in time if you have any questions on this. I do have all the demo scripts inside of a public GitHub repo, and so if you just kind of like go look for my paul.u handle, I have a repo in there called Awesome AKS, and I just basically put all my demos in there. Also, the Kubestronaut workshop that I ran yesterday, that content is on my GitHub as well. And yeah, reach out anytime. So thank you so much.
Okay, questions?
One question.
Hey, thanks for this. Since there is already a hot reload functionality, do you know if there's been any discussions of having the configuration as a resource on the API itself? Because not in all cases we have easy access and are able to actually put files on the control plane nodes and.
Right, right. Like storing that configuration in an external data store. I don't know. I think that would be a neat feature, but since it is the control plane, I don't know where that would live.
In the API itself?
In the API itself, huh?
Why not?
That's an interesting thought. Definitely feedback that we can take back. If you want to provide that in the Slack yourself, you can do that. Or I work pretty closely with Anish, one of the developers that works heavily in this, and we can definitely take that feedback back to him. That would be, good.
Okay.
Yeah.
Thanks.
Great question. Yep.
Okay, more questions?
Going once.
You're all ready to use token authentication, like tomorrow?
Yeah, I mean,
Okay.
I'm here all conference long, so if you have or think of any questions along the way, you can find me at the Microsoft booth. We're also doing an Xbox raffle if you guys want an Xbox or want a chance at an Xbox. But yeah, cool.
Well, thank you.
Thank you.
Once again.
Thank you, thank you.
The next session in this room is at 5 p.m., so you can join us for that for the end of a day of cloud native technology.
first. Oh, hey, it's working.
Welcome, folks, to the last session of the day for Cloud Native Day, although there will be more Cloud Native talks over the weekend. We are at the end of Friday. And to bring this to a rousing close, we have Amber and Ammon.
Amen.
Amen. Damn it. Amber and Ammon, who both work at Grafana, and are going to take us in a very novel journey through the adventure that is system design. But real quickly, before we do that, we have a short announcement.
Before you guys embark on that journey, my name is Faisal. I manage the Cloud Native Los Angeles chapter here. So those of you who are local, if and when you get a chance, please go to community.cncf.io/chapters and sign up for our chapters. We do a lot of local events. We in fact had one last week, as well as online webinars. So appreciate your time. Thank you.
Okay, thank you. And with that, take it away.
Thank you. So hi folks, welcome to this talk. It's called To Accrue Additional Technical Debt. Turn to page 52. This is a choose your own adventure system design case study. One thing I want you to get out of the way early on is if you went to KubeCon in Salt Lake City at the end of last year, you might have noticed there was a talk with a very similar structure and theme. It was literally a system design done in choose your own adventure style. And just want to point out that was a pure coincidence. We didn't even know that that was there until we'd already submitted this talk for this conference. Don't even know what's in it. So we deliberately didn't watch the recording so that we wouldn't accidentally bias ourselves into doing what they did. So if you see things that overlap or that are exactly the same and you've seen that talk, total coincidence. No idea what's in it.
Yeah, and you might notice this is a little different than like a PowerPoint presentation. We decided to go with Miro for this talk just because it's nonlinear. So we're not going to like go directly through a certain path. We're going to actually work with you and kind of jump around all over, and this is a dynamic way to do it. So we hope you like it, and if you don't, let us know at the end. All right, so jump into some intros.
My name is Eamon Ryan. I'm a senior principal field engineer at Grafana Labs. I live up in Oakland here in California. I've been at Grafana Labs for almost 5 years now, which is forever in Grafana time frame.
And my name is Amber Salome. I am a senior field engineer, also on the field engineering team. I'm from Chicago, and I've been at Grafana for about a year now. We're both on the same team, so we do a lot of work around helping out with pre-sales. We assist our sales engineers with technical requests. And we also build out like a lot of infrastructure for our teams and help out with feedback with product. Yeah, so we're excited to be here. All right, let's get started.
All right, so I'm not sure if that rumbling is me or which mic that is, but I can hear it.
It might be me.
Might be you. Oh, maybe pull it away from your face, but yeah, there we go. So what's this talk about? So it's a system design, but what system are we designing? So one of the things that our team covers, like Amber mentioned, is maintaining a system that we call the demo kit. So our team is an offshoot of Grafana's go-to-market team. One of the teams, the main team that we support is the solutions engineers. If you're not familiar with that role, they work in technical pre-sales. So when we're trying to sell the commercial versions of our software to companies, they're there to answer tech questions, do demos, things like that. And so we have a system that is run by our team that they use to do most of those demos. The existing demo system is about 5 years old. If that sounds coincidental that it's 5 years old and I said I was at Grafana almost 5 years, guess what the first thing I did was when I joined Grafana? So I rolled out this system with a teammate because prior to that, we'd basically been demoing with like Docker Compose files. But we'd just about outgrown that because now there was too much stuff to run on somebody's laptop. So we threw up a persistent system on GKE and just started rolling out Grafana products to that so that the SEs could use it to demo. But this was done very ad hoc, string and duct tape, and this resulted in like not the greatest system over time. So it's kind of like a Rube Goldberg machine sitting on top of a house of cards. Thanks AI for helping us visualize this perfectly. And so as you can imagine, it's a little brittle, it's a bit janky, it's very janky. But it works, and it has worked for some time. But when this system was rolled out, there were 7 solutions engineers at Grafana. There's like 150 now. So that's kind of a problem. And yeah, so we'll get into why that is.
Yeah, so when I came in about a year ago, we were already starting to discuss like how this had grown, what the problems were, and trying to think about what we could do to solution it. So really it was kind of like the Wild West at this point. There were dashboards everywhere, people were creating, people were deleting, really weren't sure, what was going on in this system. It also at that point was still a single region availability, so we did acknowledge that that was, a potential point of failure. Adding on to all of this, we really didn't have a lot of process and review for how we were adding assets in, who had access, everyone that had access was within Grafana, but we still didn't have a good visualization to what was going on in the kit. And like Eamon said, when we started out with less than 10 people, that's okay, but when we're growing into a much larger team, we need some more control around that. And that's how we got to our goal. So we really wanted to compile some sort of robust, controlled, automated, resilient system and take what we already had as a really good demo kit, but make it better and make it sort of the gold standard for what our teams were using to show our products to customers. But before we started to think about how do we want to change this, we wanted to make sure that we set aside some requirements to understand how things would be better going forward. So first off, definitely wanted to focus on GitOps. So everything in code, in Git, as sort of a source of truth, just so that we can have repeatable deployments. We wanted to make sure that everything was persistent. I will say in the original demo kit, everything was persistent there as well, but just reiterating that in this kit, we have observability data. We want things to be there and always accessible by our team. Another big thing that is a bit new here is kind of fine-grained role-based access controls, or RBAC. So for different teams with different levels of use, we wanted to make sure that we were locking down appropriate resources just to make sure that when needed, they could not be tampered with. Another piece kind of tying in with our GitOps flow is infrastructure as code. With the current or the older demo kit, we had some sort of bash script, but other than that, we didn't have a ton of configuration that was set in code stored somewhere. It was a lot of manual config, and that can be tricky if something gets deleted and we don't know how we did that. So that was a priority for us as well. Kind of thinking about like software development lifecycle as well and applying it to our infra work, we wanted to make sure that we also had multiple environments so we could test out changes. No one likes doing a change in prod on Friday at 5, and that's kind of the situation we were in. So having some sort of dev environment, having testing QA, and then eventually some sort of production where that would be, again, our gold standard demo environment. And of course, we're at Grafana, and we want to make sure that we're showing all of the Grafana resources in one kit in particular. So this also brought our requirement where we wanted to have a complete list of everything we wanted to demo in one environment, and then take all these pieces and have it automated in config. So that brings us to really the starting point of our talk and all these decision points. So kind of just the format for how we'll do this. We'll go through each decision point, present a number of options, and we'll see where you guys think we should go. So for our first point, it's really just trying to understand where do we want to take this project. This is kind of how our situation really rolled out. We learned that we do kind of have time and resources to address our situation. We're 5 years in, we have a demo kit that needs some work. What do we want to do? So really there's a couple ways we can go about this. Do we want to take on a big new project, completely roll out a new kit? Do we want to take our current one, patch it up, see if we can get things to par? Or do we want to leave it as is and just cross our fingers, hope things will continue to work? So I'm curious what you guys would do in this situation.
Hands up for A. B. C. We got 2 cowboys going for C in here. Let's start with B.
Sorry?
We'll start with B, because I think there was the most votes for B.
We'll start with B. All right, so patch up the old one and see if it's gets up to par. So this is a pretty good option, I'd say, and we see this happening a lot when we don't have the time to dedicate to a completely new greenfield project, but we do want to invest time and effort in making what we have better. It can be cheaper up front in terms of resources and time dedicated. But in terms of how long we can sustain this, we need to think about where our technical debt is, and this is where it's a case-by-case basis. And in our situation, we were 5 years in, and the technical debt has been accumulating, and we're getting more users, we're having more features that are necessary to demo, so this continues to accelerate our rate of mess. So we could be like Bob the Builder here and continue to patch things up, But for our particular issue, we wanted to, think a little bit more outside the box, given that we had the time and the ability to go a little farther. So this takes us back to here, because one other thing to consider is as we're patching, maybe we don't have time to address RBAC, and we only have one environment. So there also could be a situation where we're improving things, but still something might get deleted by accident, or even just part of it, and we don't have our backup environment present. So even though we're putting in a ton of work to patch things up, if we're not changing our process and putting things in code, it might all be for nothing. So we want to think about that too as we're, working through how we want to address this.
We've never had somebody delete the whole thing, but a lot of people could. So
Yes.
it's not great. We have had bits and pieces accidentally deleted over time that we got back, but it's a bit tenuous.
Yeah, like a dashboard, but luckily not the whole thing.
Not the whole Kubernetes cluster, no.
Okay. Well, knowing this, I guess we have two options now. We could just continue on and let it stay as is, or we could take on the new project. I do like that we had some people that were open to just leaving it as is, so I might go that way, just so you can explore how that might go. So, this is something, we talk about, and I think sometimes we just don't have the time to fix it, and it has to stay the way it is, and that is totally valid, and it happens. It's definitely cheaper up front at first, but in this case, without maintenance, and things will fall apart eventually, especially entropy, our smoking computer, in this case metaphorical in the cloud, but
It's also worth noting this problem, I mentioned there's now like 150 SEs. This demo environment actually got more popular than we thought it would, and it's actually used by people well outside of the org we intended it for. So it's not 150 users, it's hundreds and hundreds of users. So the mess just accelerates really fast.
all right. So kind of taking us to our last option, do we want to take on this big new project? So if I consider that, this isn't always the best option for every use case, but for us, this is kind of where we landed. We got the go-ahead from leadership, and we had to consider that this is going to take a lot of time. It's going to cost money. It's going to involve a lot of design work just to get anywhere, and we're not going to have an immediate outcome. But in our situation, it was worth the investment after 5 years and just the scale that we've grown to and are hoping to grow to in the future. Also needing dedicated engineers. So dedicated is in quotes because Eamon and I are working on the project. We like to say we're dedicated, but there's a lot of other things that our team needs to do. So we have to factor that in, that we're dedicating a lot of time to working on the demo kit, but it's not always something we can prioritize. So we need to factor in that we're going to have 2 concurrent systems for demoing and just really kind of manage expectations and how long it will take to do this. So that brings us to our next decision point. I'll pass it over to Eamon.
So our second point here is what kind of compute provider are we going to use now that we've figured out that we're going to do a whole big new project? So here, we've put in 4 choices. Obviously, there's more than this, but we don't want to be here all evening. I'm sure you want to leave at some point. We have AWS, we've got GCP, we've got Azure, and we've got bare metal of some description at the bottom here. How many say D? It would be that at the Linux conference, yes. C? We have 1 Microsoft fan in the room. B? 1 Google fan, interesting. And A? Oh, interesting. It's kind of split between the A and D, I feel like. Let's look at D first. Oh, got the sidebar in. Okay, so bare metal. And by bare metal, like you're talking about, you're either setting up your own data center, you're doing a colo in a data center, you're setting up servers in your own offices, something like that. I'm sure everybody knows doing that kind of approach is always going to be slower because somebody has to get the hardware and set it up, or unless you have this all in place already. Generally, you have less control over the regions it's going to be in because you have to have the data center set up or access to one. And that's a totally fine option if that's how your company is set up. So not saying there's nothing wrong with doing it that way. The other thing that might hamper you though on that front is like, do you have access to the right services as well? Do you have access to databases? Do you have access to roll out whatever actual like runtime environment you're going to use on top of that? Is all that there already for you? Or are you going to have to set all those things up that otherwise you could get easily on, say, like a public cloud or something? For us specifically, we didn't do that because, as you can see on the slide, Grafana doesn't have any data centers. We're all public cloud. Everything we have is on AWS or GCP or Azure. So for us, that meant that this wasn't really a good option. So we go back here, and we have AWS, GCP, and Azure. This is actually not, this is not like a trick question, but it's semi-moot in this point. We have basically the same result for all three, so we'll just pick AWS for kicks. But the result is the same here, because in terms of what we need for this specific project, AWS or GCP or Azure will give us everything that we need. So really what it comes down to, if you were trying to make this call, is does your company mandate one of them? In which case your choice is made for you. Do you have multiple available to you? In which case you're probably looking at which one your company gets the better deal from, which one is cheaper. And so that's really it. Like, it doesn't really matter, this choice, so go with whatever makes sense for you.
All right, so that takes us to our next point. We've worked through our project direction. We have our cloud provider. Now we got to think about what we're actually going to do for IAC, because this is one of our major requirements. So if we're thinking about what we can do with AWS, there's a couple of popular options. CloudFormation, Terraform / OpenTofu, or Crossplane. So any hands for CloudFormation?
No hands for CloudFormation?
Okay.
Nice, nice. Like half the room's hands went up for AWS, but then they went CloudFormation. No. Excellent.
How about Terraform? Nice.
Most of the room.
All right, and Crossplane?
2 Crossplane fans.
Crossplane users. All right, so that is a resounding answer for Terraform. Let's go down and see what that looks like. So this is the one option that we actually went with, and you'll actually notice through the presentation that when you see this like little golden circle, that's actually like our golden path. But again, not always the right answer. But for us, Terraform is the best option. One, because it's cloud provider agnostic. We never know in the future, maybe we'll have to change cloud providers. You know, maybe we're not sticking with AWS. So for us, we like that flexibility, and it also works with Grafana Cloud Resources. So there is a provider for that. So it's a really great option for us. I did want to say before I go forward, let's talk about the other options, because we did have some debate about what we could use. So first off, CloudFormation. I know, not the popular choice in the room, but it's something to consider if you're going on AWS. It is very AWS specific. But of course, this comes with hiccups. So we don't really have any templates available for Grafana Cloud Resources. And let's say you're in that situation, you did some CloudFormation, and then you need to deploy Grafana stuff. You could add additional cloud Terraform elements, but then you're in sort of a pickle where you have like 2 infrastructure automation tools, and that's not ideal. In our case, we really wanted to keep things simple. You might also run into a situation where, like we were saying, you don't want to be stuck on a cloud provider tool. So let's say our company says, hey, you need to deploy in GCP and AWS. Then you really have to reevaluate your automation tool and go back and do all that work you originally did in CloudFormation. So for us, it just wasn't a greatest option. Going back and thinking about the last one, Crossplane, we did briefly talk about this one as well. It actually does work with Grafana resources, so there is a provider available. And in this way, you would do it with Kubernetes. So it would make everything a Kubernetes resource, kind of like an operator. But in our situation, we didn't have a ton of expertise on the team, and this can make it difficult when trying to ramp up. So Eamon and I would have to dedicate time to learn it, and we'd start working, and that would be great. But once we want to roll someone else in on the project, that might slow things down a little bit, and then they'll start to run into issues where it's hard to get a timely fix in. So at the end of the day, that kind of led to us overall going with Terraform. So if you're curious about this down here, we just didn't talk about CloudFormation at all. Just because GCP and Azure, but yeah. So that takes us to the next step, and thinking about where do we want to store our configuration. So when using an IAC tool, we need somewhere to fetch those configs that we're tying in. So again, we considered a couple of different options here. So GitHub and GitLab are super common enterprise tools, but I would be remiss if we didn't talk about something open source. So Frejeho is a really popular one out there as well. So any votes for GitHub? All right, good representation. How about GitLab?
That's an even
it's kind of
split.
even. Yeah. And lastly, Frejeho.
Anybody heard of Frejo? Anybody heard of Gitty? Ah,
yeah.
It's a fork.
They're related. Yep. Yeah.
There was some, standard open source kerfuffle, and people went, we're going to go over this way. Yes.
Yes.
Usual stuff.
All right, well, it's pretty even. So let's just take a look at GitLab. So in this one, it's actually not super specific. This is kind of like our cloud provider discussion. It's really, what does your company provide for you already? If they're paying for enterprise GitLab, it might make sense to go with that one. Kind of the same deal with GitHub. For us, our company has enterprise GitHub. All of our repositories are there. And we just said, hey, this works for us. We're going to go down this route. But it is an interesting question to think, like, if I needed to use open source, how would that look? So for this tool, it's open source. You would self-host it. Just note that there are fewer features available compared to some sort of, enterprise product, but it is a good option if you want to go down the open source route. This brings us to that decision point, though. Like, our company has a tool for us. We're trying to keep this simple. We don't want to host things that we don't have to manage, so we're just going to take the easy route and go with GitHub. So that takes us down our path. Sorry, I got to follow the route. I have to stay on track.
We don't want to get lost.
Get very easily lost in this. All right.
All right. So our next point here is we have project direction. We've got a cloud provider. We've got an infrastructure as code tool. And we've chosen where we're going to keep the code. The next thing we want to do is automate the infrastructure provisioning. So we don't want our engineers to be running Terraform CLI directly from their laptops. It's fine to have that as like a break glass method when something goes wrong, but realistically you want that centralized somewhere so that everybody can look at the runs, see what the diffs were, see what actually happened. But certainly in an emergency, running them yourself could be done. So we have three major choices here that we looked at. GitHub Actions / GitLab CI/CD. They're kind of lumped together because they're loosely equivalent in functionality. We've got the TF controller, and we've got Atlantis. We have hands up for Atlantis. 2 people. 3 people. 4. Hands up for TF controller. This is FluxCD's TF controller, if you haven't heard of it. Nobody. GitHub Actions. Ooh, okay. Let's go with that. So you absolutely can automate Terraform executions with GitHub Actions. There is some instructions on the HashiCorp website that tell you how to do this, and on OpenTofu as well. And the upside is, works fine, nothing wrong with it. The downside for that is you have to set up all these actions, you have to maintain all these actions, and how they change over time. So it's kind of another set of components to worry about, although there is components involved in all of these. If you already have a robust infrastructure around GitHub Actions, might make perfect sense to do that. In our specific case, it's not the one that we happen to go with, just because we just decided that that would be like messier given how our existing automation already was. So this loops back around. So it's funny, we did not go with the popular choice in the room, so that's cool. Let's look at TF controller. So TF controller is an extension of FluxCD. It's an optional component. And the nice thing about this that you don't really get in any of the other options is that you get drift detection for free. So because it's running as basically like a Kubernetes operator, it's running in a reconciliation cycle all the time. So that means if somebody changes something that Terraform applied, it's going to come back in like 5 minutes, a minute, something like that. Whatever you set the cycle time to, which is potentially good, could be bad, because what happens if you rolled out like an upgrade to the underlying provider, and now it's doing something weird that you didn't know it was going to do, but it auto-applied the operation? Could be bad, could be good. So, bit of a tricky choice. Not the one we went for, though. So, just some extra facts on TF controller. It's a lot less mature. It's not at 1.0 yet. It was originally created by Weaveworks, which, sad days, no longer exists. The maintainers changed when Weaveworks shuttered. It looks like it's been picked up by 2 extra people, but that gave us a lot of pause over, like, should we put our production system on top of a project where we're not really sure where it's going to go, or if it's going to keep going. So that's kind of why we just veered away from that for now, but it is a really cool project. We heavily considered it. So this leaves us with the last one, which maybe people don't know about since there was no hands for it. So this is Atlantis. So Atlantis is an application you can set up on your clusters or on your Linux servers, what have you. It is designed around exactly this use case. So instead of it being like GitHub Actions where you're making GitHub Actions run Terraform, Atlantis's only purpose is to run Terraform. So it's purpose-built to do exactly this task. It works via integrating itself in your Git comments. So when you submit a PR that changes files you've told it to watch, like Terraform files or Terraform modules, it will recognize that you have changed those, and it will start doing the checks like you see in GitHub, where it will run plan against all the relevant projects, and you can choose to apply them individually or all at once by just writing a GitHub comment and say, yes, apply this, or do it selectively. And you can fix it so that so nobody can merge the PR until these are all applied, which is the way that we do it. So the nice thing there is the merge doesn't happen until the applies are successful, which is nice because in the other options, you can merge something, but that doesn't mean it's true, because maybe you merged it and it kicked off some workflows, but they failed. So Git is not actually reflecting reality there. So we liked this workflow better. It also helped that it's in wide use across Grafana internally. The teams that run Grafana Cloud, like all the stuff runs Atlantis underneath. And it's actually the most mature option. So this has been a production tool since 2017. So it's pretty well tested by now. And let's slide up here.
All right. So now that we've worked through like how we're doing our IAC, where we're storing our code, how we're going to kind of automate our input provisioning, we now want to think about like what kind of platform do we want to use to run our applications. So there's some pretty awesome, well-known options out there. We have Kubernetes, we considered VMs with Ansible, and then just to throw it out there, serverless, because serverless is cool. So any votes for Kubernetes? All right.
Cool.
How about VMs and Ansible? Nice. And serverless. Awesome.
2.5 fans.
2.5.
Yeah.
All right, so that looks like Kubernetes is our winner here. So let's go up and talk about that choice. So Kubernetes is the route that we did. We are on the cloud native track, so it's, yeah. But it is heavily used at Grafana already. So our cloud is actually run on Kubernetes, and we maintain a lot of Helm charts. So it made a lot of sense just for us to follow that deployment method, and it's a fairly well-known CNCF-supported standardized technology for containerization. So for us, that kind of made our choice pretty easy there. But before we go on to the next step, I do want to talk about the other options because they're really valid, and we actually see some customers running our software in different ways. So they're always good to consider. If we're thinking about running with VMs and Ansible, I've seen Grafana Enterprise Stacks run in this way. It is a very classic deployment method, and Ansible is a great way to deploy specific configs as code. But really, when we're thinking about cloud native and how we want to do things at Grafana, it just really makes more sense to go the Kubernetes route. Like I said, we have a lot of our tools that are deployed via Helm, and it's really powerful in that it applies a lot of like out-of-the-box resiliency, scalability, as a containerization platform, and it just fits our needs really well because we have a lot of different, tiny apps that we're running on our Kubernetes clusters and that we're observing, and it just made the most sense for us to go in that direction. So we actually looped this straight back into Kubernetes just on our little path. But just for the sake of it, we also want to talk a little bit about our serverless option because we're seeing that more and more kind of out there. So serverless really wouldn't work for our use case because we wanted to have more of like a persistent environment, and this is really important when we're talking about looking at consistent observability data. Another piece of this where it wouldn't work in our case is we don't have any serverless functions built out already. So that would be a considerable amount of work to do that for our situation. We also have legacy things that we need to connect to, and if we start to do serverless and then legacy pieces, we start to work in different paradigms, and that would, again, create more work for us. And just running serverless all the time would be pretty expensive for us. So, it just really wouldn't work in this situation, but just want to call it out that it is an option that is out there for other things. So if we loop our way back up, we've taken our decision point to Kubernetes and on to the next step.
All right. So now that we've talked about where we're going to run it, where we're going to keep the code, we've talked about what we're going to do with things that are sensitive. So secrets management, very popular. There's more tools, again, than we've listed here, but 3 of the ones that we did look at seriously is Vault, Bitnami sealed secrets, and just using plain Kubernetes secrets? Who's up for A? Like 8 people? 9? Vault, yeah. Who likes Bitnami seal secrets? 1 solitary person. 2. All right. Who likes just using plain Kubernetes secrets? Interesting. So there's a 4th one that I don't know about that people like. What's the other one? The ones that people didn't put up any hands for? Plain text? OIDC. What's that, sorry? Cloud Provider Secrets Manager. Yeah, that's fair. Okay. Sticky notes. Yeah, sticky notes on the screen. Just pick one. Yeah, so Kubernetes secrets. Kubernetes secrets, if you've used Kubernetes, you know how these work. If you haven't, they're just another object type Kubernetes supports. But all they're really doing is storing the secret base 64 encoded. They're really easy to work with. A lot of Helm charts already work with them. The challenge there is that they're base 64 encoded, which means they can be base 64 decoded. You just run a command and you can see what the secret is. Is that secure? Kind of. There's like warring factions on whether Kubernetes secrets can be considered secure and whether these other pieces of software that aim to make them more secure even really have a point. So the way that this works is one side says Kubernetes secrets aren't secure because you can just decode them. And that might be reasonable. The other side says, well, if your Kubernetes cluster is secure, are the secrets not secure? If the only people who can log into the Kubernetes cluster are admins, or you've set up your Kubernetes RBAC to the point where nobody can read the secrets except your like core admins, is that not the same as having it in a vault or something like that? Because eventually you have a privileged enough set of admins who can read the secrets. And you have to trust them eventually. And is this not the same thing if your cluster is locked down? I would argue that it is. So our clusters, the actual Kubernetes clusters where we're running these workloads, the only people with kubectl access is our little team. The people who use the systems provided by the clusters do not log into the Kubernetes cluster. They only log into the apps that run on the cluster. So we view that as still secure. However, there is a challenge there because if you're trying to GitOps, everything, then you have to put the secret YAMLs into Git, which means if your GitHub repo is not hidden from everybody, then you reveal the secrets to people outside your team. Now, we could restrict view access to the Git repos, but we didn't want to because we want people to be able to use them for reference to see this IAC system working and be able to reference that for customers who want to build a similar thing. So we want the repos to be readable, but we don't want the secrets to be readable. So that meant that while we like Kubernetes secrets, we need something that layers with that. So we'll talk about Vault next. Vault is really interesting. So very mature project, been around for years, HashiCorp product, has loads of ways you can deploy it, and had lots of backends you can sit on top of, and different clouds, and like you can hook it up. Its backend can be AWS Secrets Manager, for example, and people are used to using that. There's some challenges with using Vault, though, that we came to. One is that it's not open source anymore. They changed the license to the business source license, I think sometime last year, when they relicensed most of their stuff, and all that stuff went down. Also, IBM recently finished acquiring HashiCorp, and I'm not saying they're going to kill it, but acquisitions cause things to be killed. So who's to say? So that gave us pause. It is a bit of a more complex setup. It works a bit differently to a lot of other things with like the sealing keys and the unseal and the way that all works. It's a bit kind of strange. Does need its own separate storage backend. So then you've got a secret store which stores its secrets in another place. And it seems, it kind of seemed messy. We didn't really like that. And then finally, the bit that really kind of sold it for us to take the other option was the fact that if you are using Vault and you're using GitOps, your references to your secrets they'll look like variables. There'll be like a certain placeholder with like a certain wrapper brackets around it so that you know it's a secret that Vault is going to grab and replace in your runtime. But the challenge with that is you don't know if it changed. So someone can go into Vault, replace the secret content, and what you have in Git does not change. So now you have changes that are not tracked because the placeholder remains the same. And so we were like, nah, with all these reasons, we're not going to do this. So that led us to using option B, which is Bitnami sealed secrets. Judging by the number of hands, I'm guessing the large number of people don't know what this is or have never used it. That's totally fine. The basic idea is it is a way of using Kubernetes secrets, but encrypted. So Bitnami lets you, they release a CLI called kubeSeal, and that just uses a certificate to encrypt your secret, and it will spit out a new Kubernetes YAML called a sealed secret. It looks just like a regular secret, except you can't read the content. You can't base64 decode it. You could try, but it won't help. A little bit. And so the nice thing about that is the way that works is you create the sealed secret YAML, you apply it to the cluster. There is a sealed secrets controller running in your Kubernetes cluster that has the private key. And it automatically reads sealed secret YAMLs and decrypts them into secret YAMLs. So Kubernetes operates like it's just using regular secrets. You don't have to change the references in any of your Helm charts or anything like that, because it's decrypting them to regular secrets. So this is an extension of the model where you're saying the secrets in Kubernetes are secure because Kubernetes is secure. The bonus, though, the thing that we really liked about it is you can put these sealed secret YAMLs in Git and they're safe because you can't decrypt them without the key. And since the encrypted value is in Git, it means if you change the value and you re-encrypt the file, the encrypted values will change. So you know they have changed. The diff will be present. And it'll just be, encrypted string was changed to different encrypted string, but you know it changed. So now you're tracking everything. So we liked it for that reason. But what about the applications? So we've got infrastructure, we've got automation for infrastructure, now we have applications that we want to deploy. If you're doing GitOps and you're pushing applications to Kubernetes, there's two major games in town, and that's Flux CD and it's Argo CD. They're CNCF graduated projects, both extremely mature. Don't have a strong preference for either one here. They're both great. There might be other ones you're not aware of. These are the two big ones that we actually evaluated. So we'll just slide over to Argo first here. Argo is great, mature, well used, synchronizes objects from Git into Kubernetes, has a native UI, works great. The only reason that we didn't really pick it is because we don't use it at Grafana. We use the other one. So there'd be a higher learning curve to roll out Argo. It seemed a bit silly to go the opposite way to the rest of the whole company, so we just didn't do that. But nothing wrong with Argo. Scrolling up to Flux, same thing, mature, syncs objects, works great. Flux actually, a major difference is it does not have a native UI. But there are various projects that will give Flux a UI if you want. You can run it without one, and you can operate it purely off of like metrics and logs, and you can visualize those in a tool like Grafana. Hey. And we're already using it widely across the company, as I mentioned, so that was a logical choice for us. So we did that. We did have to make a choice within Flux, though, which is do we want to Flux things locally or remotely? And if we look at remotely first, just because it's the one that we didn't do, this would be you're setting up your Flux components on a central cluster, like an admin cluster, and you're telling it to synchronize objects out to remote Kubernetes clusters. This is great because you've got less duplicated config, you've got a central place to sync things to, and that makes sense. Downside of this is you created a single point of failure. If there's something wrong with that cluster, if there's a network connectivity cut to that cluster, then the other ones will not be synchronized anymore. So might be fine. Maybe you're all in one region, maybe it doesn't matter to you. But in this case, we decided not to do that. We decided to do it all locally. And so when you're doing Flux locally, what you're doing is setting up the Flux components on every Kubernetes cluster that you're doing, and each one is reaching out to Git individually and synchronizing itself. Now, the upside of that is the clusters are more independent, they're more resilient, they operate separate from each other, they don't have a tie-in to an admin cluster. The downside is you have a little bit of duplicated config, but you can automate all that away. So it's just duplicated in Git. It's not a big deal because the way we actually do it is we deploy all the Flux components with Terraform, so that automates that. And then Flux handles all the rest of the applications. So some people think you shouldn't Terraform applications because Terraform is an infrastructure automation tool. The way we kind of looked at it was Terraform should only deploy the applications that are like there to bootstrap the clusters that we're deploying. So Terraform deploys enough to get the synchronization going, and then everything else is deployed by a Flux. And that made logical sense to us, so we just did it that way.
All right. So we're getting towards the end of some of our decision points, but one that was also pretty big for us was how we wanted to approach high availability and if it was something we wanted to approach. So really there's two options here, doing something regional, having a sandbox, dev, prod, maybe a couple prods in different locations, or one deployment to rule them all. So I'm just curious, does anyone have situations where they would do situation B? And I know that's something that we did before, but any hands for that one?
No one for B?
No one for B. Yeah. No, single instance, kind of like. Okay, and how about A?
Everyone else is A, or is everyone else too tired to put their hands up?
Yeah. Or there's other options. I think we only put 2 here, but there's just so many different ways to do it, and we didn't even go into hot, cold, or any of that kind of stuff. But just thinking about how we want to do regionality and how many copies you want to deploy was something we had to consider. So just kind of thinking about it, the one deployment situation, I think it works really well for the original use case where we only had 7 users. It was okay for us to have a smaller environment, just one of them, and we didn't have to worry about having it in so many places. But I think this changes for situations where we have more people relying on it, and we need higher availability because it is just more critical of a system. And in our case, we're a fairly distributed team now. We have team members across the world. We don't want them to have to worry about latency or access or anything like that, or a single point of failure. So as we've scaled, it's just made more sense to think, okay, we need a couple more instances here just in terms of reliability. Because we're really trying to avoid this situation of maybe an outage occurs and we won't even know the impact until later on because we don't know our schedules for all the demos that are going on anymore. We don't know what everyone's doing, and we want to make sure that it's available for them by default so that everyone will be able to enjoy the same amount of business continuity. So I think, yeah, it was a good setup when Eamon and our fellow teammate first started, but now we're kind of at the drawing board where it was really actually important to us to have it in multiple regions just to support our different teams. So we have 3 different team groups in AMER, EMEA, and APAC. So we wanted to make sure that at least one region would have a prod environment. But it's interesting to think about, actually for dev and sandbox, we're following this pattern of just one environment because in that situation, it made sense there. So we're actually kind of doing a little bit of a combination because if dev and sandbox go out, we understand that it's okay. It's not critical for our business to continue. And our prod environments are the ones that we want to be replicated out. So we made specific decision points there because, in this case, we're only deploying 5 environments versus managing I think it would have been 9 just to start out. So I think this is a case-by-case thing because we sometimes always think we always need duplication, but not always. I've blasted Sandbox so many times now and no one's ever complained.
That's what it's for. That's
exactly.
What it's for, yeah.
No one within our team has complained.
Yeah, so the Sandbox is only used by our smaller team, which is only 8 engineers, and it's there so that we can break it. Dev is actually open to everybody and has a bit looser controls, so people can manually create dashboards and things like that, whereas prod doesn't let them do any of that. So that's the way that works. We decided one dev was okay for now. We might revisit it, but it's been okay so far.
Yeah, exactly. And if we start doing multiple work streams too, we've had sometimes oh, I'm working on this environment, can you deploy your changes to this environment? And we've balanced between dev and sandbox, but as more people work on features, it could grow. But yeah, this takes us to the last point, I think.
No, this is
the next point. So one other piece of automation we wanted to think about was particularly with Grafana. So automating dashboards and data sources was really important to us and was one of our requirements as well. So this might seem oh, this is just a small piece of the work, but we actually had some extensive conversations about how we wanted to do this because Grafana offers a couple of different ways. So we have our Grafana operator, Terraform, and then Hacky Bash script, which I lovingly say Hacky, but yeah. So any votes for the Grafana operator? Nice. Ooh, we have Grafana. Do you guys use Grafana operator? I'm just curious. It's, I don't know, exciting.
Or do you just like Kubernetes
I just
operators?
like it.
I saw a nod for that one, yeah.
Yes.
It's actually nothing to do with metrics. So it's to do with you can have a CRD for a dashboard, and it will load it into Grafana.
Yeah. votes for Terraform. Ooh. All right, Hacky Bash script.
That's a lot of people voting for the Hacky Bash script. Love
Yeah,
it.
let's do it. All right, so Hacky Bash script. So we decided not to go this way just because, sorry?
Zoom in.
Oh, zoom in. Ah, yes,
Yeah.
the meme is important. So this is what we previously did for our old demo kit, and we decided that we really needed to rethink how we were doing this just because it created quite a bit of pain, especially with maintaining it. It wasn't automated. We were just manually deploying the script. You know, you might have this experience where you are doing some like off-the-grid API call, and then they change the API, and then your script breaks, and you're like, oh no. So we wanted to like avoid that and have a more robust provider that we were relying on to deploy these resources. So if we go back up, let's talk about the second option that had a good amount of votes. So the Grafana operator. So like Eamon mentioned, this is working off of CRDs. So our operator is something that we would run in Kubernetes. It would run in a loop to sync everything out there. And then you'd have specific CRDs for different Grafana resources, such as dashboards, data sources, and so on. And it's really nice because we're using Flux CD to automate things, so we could just tie that in as well. But thinking about this piece, you know, we really, really heavily considered it. I think Eamon and I had multiple discussions, and we went back and forth, and we just decided that it wasn't, you know, worth us changing our paradigm because we were already using Terraform, and it just made more sense to kind of consolidate the tools that we were using, but it's definitely a valid way to go about it in like a Kubernetes-centric way. So going back to our choices, this leaves us with Terraform, which is ultimately the option that we picked. Like I said, we were already using it, so it fit with our pattern. We could tie things in as well with Atlantis. And I mentioned that we talked about it a lot. This is because we actually had a sticking point, and we had to evaluate like what level of risk we're okay with and how this would work for us. So when working with the Terraform provider, the data sources don't have as granular permissions because we don't have data source folders. So you would set the permissions on the folders. In prod, this doesn't really matter because we locked everything, or we plan to lock everything down. So no one can edit the data sources, no one can edit the dashboards. But in dev, we have things a little bit more open. So in this case, we want people to create dashboards in dev, but we don't want them to mess with the data sources. Here though, the way it had to go with Terraform, we can't really control that. So there is like a little piece of risk where someone could go in and change the data source. We're accepting that risk because it doesn't impact prod. And you know, at the end of the day, we have everything in config. So if something really gets messed up, we can just reapply and it'll be okay.
It'll also get picked up on the next time we run Terraform anyway.
Yeah.
Next time a PR comes in Atlantis to come in and say, that's wrong, it'll just change it. So it's okay. It'll only be wrong for a brief period of time, and it's only in dev.
Yeah, exactly. All right, and
yeah, this brings us to the last decision point of the talk, which is around telemetry. We're specifically going to talk about metrics just because we don't have time to talk about all the other signals like logs and traces and profiles. But as an observability company, we obviously want to get telemetry data out of the system that we've built. So for metrics, that gave us a couple of major choices, Prometheus, OpenTelemetry, or maybe a bit of both. Hands up for Prometheus. Half, maybe a third. Hands up for OpenTelemetry. More than I thought, excellent. Hands up for both. Less people, all right, let's do OpenTelemetry. So OpenTelemetry, if you're not familiar with it, is a very community-driven set of standards that's coming out around standardizing how observability telemetry should look. So metrics, logs, traces, profiles, bunch of great individuals and lots of software vendors all agreeing on this is how telemetry should look in a standardized way so that when people move from observability system A to B to vendor A, B, C, D, E, they don't have to re-instrument their code for any of these signals. They should just be compatible with everything because it sucks when you are the end user and you have to change all of this stuff. Great project, fantastic. It is definitely becoming more and more of a standard as stuff goes on. And so it's totally fine to have that in our system, and we do have that in our system. The challenge we have though is that because we are an observability vendor, and because our stuff supports both Prometheus and OTel, we will get people who are on one side of the fence or the other. Or maybe they're in between, where they're like, oh, I want to see this with Prometheus, though. You can't just show me the OTel. And we're like, yeah, that's a good point. So in our specific case, we did need to see more than just OpenTelemetry, but totally fine option, absolutely nothing wrong with that. Let's look at Prometheus real quick. It's basically almost the inverse of this, but Prometheus, we love Prometheus at Grafana. About half of the Prometheus maintainers actually work at Grafana, so we're big fans of it. But same situation as before, except inverted. We will get people who we'll try and show them the Prometheus stuff, and they'll say, oh, I only care about OpenTelemetry. And we're like, damn it. So that wouldn't really work. So we just went with both. So our own backends, both our open source backends and our cloud backends, they support both types for metrics. This is also true for like logs. We support various types of logs, but including OpenTelemetry logs. Traces, we do Jaeger, Zipkin, and OTel. And the profiling standard for OTel is actually being developed alongside, like being heavily like pushed from our end anyway, from the folks at Pyroscope, if you're familiar with them. So we slap both of them together. We show a bit of Prometheus, a bit of OpenTelemetry, so we can demo them side by side, show people the differences, show people that both are totally fine, and support just more varied demo scenarios, and that works great. We even have our own collection agent, Alloy, that supports all of the signals together. So you don't have to have a metrics agent and a logs agent and a traces agent. We can just slap them all together in one, and it works great.
All right, so this takes us to the end of our journey, actually. Well, not fully the end, and we'll talk about that in a second, but did we actually make it to, the majority of our goal? And if we think about the progress we made, we did hit a lot of things. So we have a project direction going completely greenfield. We decided on a cloud provider, so AWS, deploying Kubernetes on it, so EKS, and then within that using Terraform to automate everything, pulling in all of our configs into GitHub, and then within Kubernetes deploying sealed secrets using FluxCD to manage our applications, and then settling on a semi-multi-region multiple environment deployment. For our Grafana resources as well, we pulled in Terraform, and then on top of all this, because we're Grafana and we want to talk about telemetry, we have done a lot of deployments with telemetry with Prometheus and OTel. So I would say that we kind of are on the way to having like our fully golden standard demo environment. It's very automated, very controlled with the RBAC setup, and we're hoping it's robust and resilient as could be. But you'll see this diagram on the right, and it's actually kind of what we started with before we built anything out. So we really wanted to be intentional about how we plan to deploy things, what we're deploying, and what it would look like, just so that we can make sure that our system was solid going forward and people would understand what we're working on and can jump in as needed. So I'm sorry, it's a little small, but all the logos for the different tools that we used are in here.
And so the logical next question at the end of one of these talks is always, what are you going to do now? So we probably have about, I would say, 85 to 90% of what we set out to do done. Obviously, a project like this is never fully completed. You're going to maintain it and iterate on it over time. But in terms of all the milestones we wanted to hit before we called Demo Kit 2.0, like GA, we're almost there. A couple of things we want to do is set up RenovateBot, which is great at filing PRs for you automatically, with just version bumps for things. You can limit it to be like, only give me patch releases, so that it doesn't give you a major bump and then tries to bump up a container image and then the whole thing breaks because the config has changed. So we don't want that. We want to set that up. We used it before. It works great. We're also building out some automation so that users can come into the dev Grafana, build out like a whole demo, and have an easy process to get that promoted into the production one without them having to be GitOps experts. So we don't want them to have to do that. They have enough to do. So that'll be great. The other thing that might come up is we might end up deploying some copies of these demo kit environments to other cloud providers. So we put it on Amazon. The old kit was actually on Google, but this one is on Amazon. But we might end up putting some on Google and some on Azure as the need arises. Don't have that as a current plan. But with the automation that we've built out, this wouldn't be that hard. We would just have to change some of the base modules to deploy like GKE instead of EKS or AKS. And I know if you're somebody who's ever used multiple versions of cloud provider managed Kubernetes offerings, you'll know that they're not the same. They're just kind of the same. So we've dealt with that, and we know how to deal with that, so it'll be okay, we hope. Something else we haven't done is we have not deleted the old environment because we're not fully there. We have a list of like feedback form items for things to still cut over, but we're getting close, and then we're going to have a party when we delete this 5-plus-year-old Kubernetes cluster, and people will be mad because they'll have missed the 85 warnings we gave them about the impending doom of the old environment, of course. The other thing that's kind of cool is we've already deployed a bunch more copies of what's effectively one of these demo kit environments for very different purposes. We've had some product management group at the companies, or product management groups at the company, and some other engineering teams who were like, hey, is there any chance we could get one of those for this limited time purpose? And we're like, you know, if you'd come to us like 6 months ago, we'd have been like, absolutely not. Like, we don't have stuff to give you that. But now, like, we can knock that out in a couple hours and get you like a fully built out environment for your own purpose with your own set of RBAC and all that. And that's already happened. We've added like 4 or 5 extra ones that hopefully we won't have to keep long term, but we'll see. But it's cool to see that used by groups that we didn't even envision using it to begin with. So that's been really fun to see.
All right, so this brings us to the end. So I think we have a little bit of time for Q&A, but just want to like do a quick pitch. If you want to find us on LinkedIn or social media, here are our contact. And if you're interested in learning more about Grafana, come to the booth. We're at booth number 421, or just check us out online. But thank you all for coming to this talk, like at the end on a Friday. Yeah.
Thank you.
Okay, we have time for a couple of questions.
I was curious if there was any thought given to like setting up some kind of disaster recovery or backup restore, or if it's just because it's a demo environment that was just not a concern for like trying to back up dashboards and stuff like that people are building.
Yeah, we haven't really talked about it yet, but I'm hoping that we have a lot of the stuff in place.
Yeah. So yeah, I would agree. Like, we haven't had like extensive discussions on it, but I think that's also because the core purpose of this is it is just for demoing. The only purpose of the historical data is that it's nice to have for demos, to be able to like look at graphs and like look back in time and see what it was. But the actual content of the data is like sort of irrelevant. It's important that it exists and it's not flat lines, but it works for demos as long as it's there. So even if it got like blown away today, the actual app configs don't matter. That's all in Git. We can roll that out in like no time at all, as long as it takes the automation to run. The only data that's really kept historically is the telemetry data, but we're actually not storing that in like open source Prometheus or anything. Those are actually going to our SaaS Cloud's backend, which is hosted by the actual R&D engineering teams, which ultimately though that's still in the cloud provider, but they're doing like the actual high SLA production level stuff. So that's even more resilient than what we built. These demo kits environments are kind of a hybrid of what we have in our SaaS cloud and then connecting to everything else we can possibly connect Grafana to. That stuff we're hosting, but that stuff, again, those are configs we can roll out in 5 minutes anyway. So we don't really have like critical historical data, I guess, so it's not as important.
Yeah, I think like our biggest demo like case needs only like 24 hours of data. So yeah.
Could you give a quick overview of the logging and tracing systems you guys decided on after after that? You mentioned that you didn't have time to go over them in detail, but I would like to know what technologies you used to implement them.
Yeah, so the logging tracing system that we ended up using, so we make those as well at Grafana, and I can tell by the raised eyebrows that people didn't know that. Great reason to come to the booth. We actually make backends for metrics, logs, traces, and profiles. So we have a logging backend called Loki, open source. These are all open source. Open source backend for tracing called Tempo, and an open source backend for profiles called Pyroscope. And so we could deploy those as open source in the kit environments and store the data there. Ultimately, they store stuff in object storage. For metrics, we're actually not running Prometheus, we're running Mimir, which is Prometheus API compatible. So end users think it's Prometheus because it speaks PromQL, that works exactly the same, but it's actually more distributed Prometheus. Same with Loki, Tempo, Pyroscope. But all those we run in Grafana Cloud as well, and we're just sending the data there, but it's the same open source deployments. But if anybody's interested in those projects, come talk to us at the booth tomorrow. We'll be there, but there'll be more time.
Yep, the LGTM stack, so you can actually get stickers for it and you know, put it on your laptop and yeah.
Well, thank you very much. We are out of time because there's going. Oops, sorry. Let me get not next to the speaker. We're out of time because there's going to be a BOF in this room in a couple of minutes. So Thank you all for attending. This is not the end of the evening. There's several BOFs. There's the SCaLE Ignite talks in the big room, and probably a number of conference parties. And then we will resume tomorrow morning at 11:30, I think, with more cloud native talks. So, see you then.
Super. Thanks all.